Hello there, and welcome to Life Beyond Seen, where the strange and the quiet find each other at the edge of what we think we understand, and the world opens up just a little wider than it did before. Tonight, we are going somewhere that sits at the far edge of northern Mexico, past the cattle ranches and the dry riverbeds, past the last paved road and the last reliable phone signal, out into a stretch of desert that the locals have been calling, for a long time now, the Zone of Silence. Not a nickname given lightly. Not a name invented by a travel writer looking for something dramatic to put on a map. A name that arrived the way most honest names do, because something kept happening there, and people needed a word for it. Picture the Chihuahuan Desert at night. Not the romanticised version with a single coyote howling at a full moon. The real thing. The flat, almost featureless scrubland stretching toward Durango, the sky so dark and so wide that it stops feeling like sky and starts feeling like something else entirely. The air is dry and cool after the day's heat has finally let go. There is no town light on the horizon, no road noise, no aircraft blinking overhead. Just the low shapes of creosote and lechuguilla against the dark, and a silence so complete that you start to notice the sounds your own body makes. Your breathing, your heartbeat. The soft crunch of sand under your feet if you shift your weight. This is the Chihuahuan Desert in the northern Mexican states. Chihuahua, Durango, Sinaloa, meeting at a rough and mostly unmarked border. And somewhere within that triangle of states centered around a broad flat basin called the Bolson de Mapimí, there is a patch of land, maybe 50 kilometers across, that has accumulated one of the strangest reputations in the entire Western Hemisphere. Not because of buried gold, not because of ancient temples or lost civilizations, because of something harder to explain and in some ways harder to dismiss. Radio signals that go dead, compass needles that spin without settling, lights that move low over the desert in patterns no aircraft should make, and a United States military missile that left New Mexico headed for Utah and somehow ended up here instead. The area sits near 26 to 27 degrees north latitude, in the heart of the Bolson de Mapimí Basin. It is, by most measures, one of the more remote and inhospitable places in North America, and it has a name that, once you hear it, tends to stay with you. Zona del Silencio, the Silent Zone. Before we go any further into the desert tonight, I'd love to know where you are listening from. Are you somewhere warm, somewhere cold, somewhere already quiet, or somewhere you're trying to make quiet? Is it late where you are, the kind of late where the house has finally settled and the world outside has gone still? Whatever the answer, I'm glad you're here. And if the kind of slow, careful storytelling we do on this channel is something you find yourself returning to, it would mean a great deal if you gave this video a like and subscribe to Life Beyond Seen. It genuinely helps this little corner of the curious and the calm find more people who might need exactly this sort of company at the end of a long day. Now, the Zona del Silencio. The name itself is worth pausing on for a moment, because it does not mean the desert is literally silent in the way a sealed room is silent. The desert has its own sounds. Wind across flat stone, insects at dusk, the occasional distant call of something moving through the scrub. What the name refers to is something more specific and more unsettling. The claim, repeated by workers, researchers, ranchers, and eventually journalists and tourists over the decades, is that in this particular stretch of the Bolson de Mapimí, radio signals fail. AM radio goes to static. Shortwave cuts out. Communications equipment that works perfectly well 50 kilometers away simply stops working reliably here. Some accounts mention compasses behaving strangely, the needle refusing to hold a steady bearing, drifting in ways that experienced desert travelers found difficult to explain. Other accounts describe equipment malfunctions of a more general kind. Interference, feedback, instruments giving readings that made no sense. Now, some of this could be folklore. Stories grow in remote places. A radio that crackles in the heat becomes a radio that was silenced by the zone. A compass that drifts near a rock outcropping becomes a compass bewitched by invisible forces. That kind of growth is natural and human and worth keeping in mind as we go. But what makes the Zona del Silencio different from most places with a spooky nickname is that some of what has been reported here is documented, tested and confirmed, at least in part. The geology is genuinely unusual, the electromagnetic properties of the soil are measurable, and the event that first brought serious outside attention to this stretch of desert was not a ghost story or a local legend. It was a missile, an actual United States Air Force missile, with a serial number and a launch date, and a recovery operation that required diplomatic negotiation between two governments. That is where the modern chapter of this story begins, and it is about as concrete as anything in this desert gets. But before we get to the missile, it helps to understand what kind of place the Bolson de Mapimí actually is, not as a mystery, but as a landscape. Because the land itself, the geology, the minerals, the dry lake beds, the particular quality of the air and the soil, turns out to be deeply relevant to everything that gets reported here. This is not a place that is strange despite its physical nature. It may be strange because of it. The Bolson de Mapimí is what geographers call a closed basin. Water flows in from the surrounding ranges when it rains, which is not often, and it has nowhere to go. No river carries it out to the sea. It simply evaporates, leaving behind flat, pale lake beds called playas, cracked and pale and almost perfectly level, stretching across the basin floor like enormous pieces of dried paper. The soil in and around these playas contains elevated concentrations of iron minerals, including magnetite, which is one of the naturally occurring magnetic minerals found in the Earth's crust. The surrounding rock layers contain other metallic compounds as well. The region sits at roughly 1,100 meters above sea level, which is high enough to affect atmospheric conditions without being dramatically mountainous. It is, in short, a place with a very specific and somewhat unusual set of physical properties. And within that basin, in this particular part of northern Mexico, something keeps happening that people keep coming back to explain. The zone has been studied, visited, mythologized, dismissed, reconsidered and studied again. Scientists have taken soil samples and electromagnetic readings. Journalists have written features comparing it to the Bermuda Triangle. UFO researchers have camped here for weeks, watching the sky. The Mexican government has designated a large portion of the surrounding area as the Reserva de la Biosfera Mapimí, a protected biosphere reserve, partly because of the region's genuine ecological value. Rare tortoises, unusual plant communities, a fragile and largely undisturbed desert ecosystem. And through all of that, the science, the folklore, the tourism, the biology, the geology, the question at the centre of it all remains stubbornly interesting. What is actually happening here? Is there a real physical phenomenon at work, something the geology produces that affects electronics and navigation? Or is this a place that became famous for strange things, and then attracted people who were already primed to experience strangeness? Or, as is often the case with genuinely interesting places, is it some complicated mixture of both? Those are the questions we're going to spend the next while exploring, carefully, without rushing past the details that matter. We will look at what the land is made of, what has been measured, what has been seen, what has been documented, and what remains genuinely unresolved. We will follow the story from a missile launch in 1970 all the way to the present, where visitors still drive the rough dirt road into the basin, and some of them still find their phones behaving oddly, while others notice nothing unusual at all. The Zona del Silencio is, depending on who you ask, a geological curiosity, an electromagnetic anomaly, a UFO hotspot, a conservation success story, a media invention, or simply one of the quietest and most beautiful and most disorienting stretches of desert in North America. It is probably several of those things at once, and the story of how it became all of them at the same time is in itself worth telling slowly. So let's begin where the modern legend has its clearest and most verifiable starting point. Not with a strange light in the sky, not with a compass spinning in the dark, with a rocket. A specific rocket, launched on a specific date, from a specific facility in New Mexico that was supposed to land in Utah and instead came down here, in the middle of the Bolson de Mapimí, in a way that no one has ever fully explained to everyone's satisfaction. On July 11th, 1970, a rocket designated the Athena RTV, a re-entry test vehicle operated by the United States Air Force, was launched from White Sands Missile Range in southern New Mexico. White Sands is one of the most active and well-documented military testing facilities in the world, a vast stretch of pale desert in the Tularosa Basin, where the US military has been conducting missile and weapons tests since the 1940s. The Athena was a relatively modest vehicle by the standards of the era, not an intercontinental ballistic missile, not a weapon in the operational sense, but a test platform designed to gather data on re-entry conditions. The intended target zone was somewhere in Utah, several hundred miles to the north. The flight path was planned, the trajectory calculated, the systems checked, and then it launched, and it did not go to Utah. Instead, the Athena travelled roughly 500 miles in the wrong direction and came down in the Chihuahuan Desert of northern Mexico, somewhere in the Mapimí Basin. Exactly how far off course it ended up depends on which account you follow, but the basic fact is not disputed. A US military missile landed on Mexican soil without permission, without warning, and without anyone on either side being entirely sure where it had gone for a period of time. That is not a small thing. It required diplomatic engagement between the United States and Mexico to authorize a recovery operation. The Mexican government had to formally permit US military personnel to enter the country, travel to a remote desert region, locate the wreckage, and remove it. That process takes time. It involves paperwork and phone calls and careful language, and it is the kind of thing that gets recorded and remembered. The recovery team that eventually made its way into the Mapimí Desert faced a problem that might seem obvious in hindsight, but apparently was not entirely anticipated. There was no road. The Bolson de Mapimí in 1970 was genuinely remote. There were ranching tracks and rough paths used by locals, but nothing that could support the kind of heavy equipment and vehicle convoy needed for a military recovery operation. So the team did what military operations do when they need to get somewhere difficult. They built a road. A temporary access track was constructed across the desert floor, cutting through the scrubland and dry lake beds to reach the area where the missile had come down. That road, rough and unpaved as it was, became one of the stranger legacies of the incident, because it did not disappear afterward. It stayed. And years later, it became the route that tourists and researchers and curious visitors would use to reach the place that was by then being called the Zona del Silencio. The recovery itself was not quick. Working in that terrain, in that heat, with equipment that had to be brought in over a freshly graded dirt track, took real time and effort. And during the operation, members of the recovery team reportedly encountered something that would later become one of the central pieces of the zone's mythology. Their radio equipment was not working properly. Communications were unreliable. Some accounts described the interference as intermittent. The radios would function normally for a while, and then lose signal or produce static at unexpected moments. Other accounts are more dramatic, suggesting near-total communication failure in certain parts of the basin. The precise details vary depending on who is telling the story and how many years after the fact they are telling it, which is a caveat worth holding on to. But the core report that the recovery team experienced unusual radio interference in this specific location appears in multiple independent accounts and is not simply a rumour that materialised later. Some members of the team also reportedly noticed compass irregularities, needles that drifted or failed to hold a consistent bearing. This kind of report is actually less surprising than it might sound, given what we know about the geology of the region. The magnetite-rich soil and iron-bearing rock layers in the Bolson are exactly the kind of material that can produce localized magnetic anomalies strong enough to affect a compass. But in 1970, the recovery team was not thinking about geological explanations. They were in a remote desert trying to find a missile and their equipment was misbehaving. That tends to make an impression. Now it is worth pausing here and being careful about what we can actually claim. The Athena missile's deviation from its intended flight path is real and documented. The diplomatic negotiation between the US and Mexico is real. The road construction is real. You can still drive a version of that road today. The radio interference reports come from multiple sources and are consistent enough to take seriously. But the degree of the interference, the exact behaviour of the compasses, and the specific details of what the team experienced have been filtered through decades of retelling, through journalists who are interested in making a good story, and through a cultural moment in the 1970s when the Bermuda Triangle was at peak popularity and people were actively looking for similar phenomena in other parts of the world. The Mapimí Basin, with its missile incident and its radio problems and its remote, eerie landscape, arrived at exactly the right moment to be mythologized, and it was. The question that tends to follow the missile story, the one that gets asked in every article and documentary about the zone, is whether the Athena's dramatic deviation was caused by the zone itself, whether the same forces that interfered with the recovery team's radios somehow pulled the missile off course in the first place. It is a compelling idea. It makes narrative sense. A place that disrupts electronics and scrambles compasses could, in theory, interfere with a missile's guidance systems. If the electromagnetic properties of the basin are unusual enough to affect ground-level radio equipment, might they not also affect an airborne vehicle passing over or near the region? The honest answer is probably not, and here is why. The Athena was not flying over the Mapimí Basin when it went off course. It launched from New Mexico and deviated before it ever reached Mexico, at least according to the most straightforward reading of the trajectory. Missile guidance failures are not rare events. They happen for entirely mundane reasons, including sensor errors, software failures, fuel inconsistencies, and weather. The Athena was a test vehicle, which means it was, by definition, being pushed to its limits, and was more susceptible to failure than an operational system. The most likely explanation for why it landed in Mexico instead of Utah is a guidance system malfunction of the ordinary kind, the same type that has sent test vehicles off course on dozens of other occasions at dozens of other facilities. The Mapimí Basin did not reach out and grab it. It simply happened to be where the missile came down. But that explanation, accurate as it probably is, does not make the incident any less interesting. Because the missile landing here, in this particular basin, with its unusual geology and its subsequent radio interference reports, set in motion a chain of events that turned a remote and largely unknown stretch of desert into one of the most talked about anomaly zones in the Western Hemisphere. The missile did not cause the zone's strangeness, but it caused the zone's fame, and fame in a place like this has a way of generating its own evidence. There is something worth sitting with here, which is the sheer improbability of the whole thing, even stripped of any supernatural element. A US Air Force missile launched from one of the most carefully managed test facilities in the world somehow ended up in a remote Mexican desert that happened to have unusual electromagnetic properties, that happened to be near a region with an extraordinary meteorite history, that happened to be in a basin where lights had been reported in the sky for years, and that happened to be accessible enough to become a tourist destination once someone built a road to retrieve the missile. If you were writing a novel, an editor might tell you that was too many coincidences. But deserts are large, and coincidences are real, and sometimes a story just accumulates details the way dry lake beds accumulate mineral deposits, slowly, over time in layers. The road that the recovery team built in 1970 was by most accounts a fairly basic affair. Graded dirt wide enough for military vehicles, running roughly 50 kilometers from the nearest accessible point near the town of Ceballos, Durango, into the heart of the basin. Ceballos itself is a small community, a few thousand people, built around the desert economy of cattle ranching, and later, the modest tourism that the zone's reputation brought in. In 1970, it was primarily a ranching town, and the arrival of a US military convoy must have been a genuinely remarkable event. Large vehicles, foreign personnel, equipment, all moving through a landscape that rarely saw anything more dramatic than a cattle truck. Local residents would have watched, local residents would have talked, and their accounts, combined with the reports from the recovery team itself, would form the first layer of what became the zone's legend. The missile was recovered eventually. The wreckage was loaded onto vehicles driven back along the new road to Ceballos and transported out of Mexico. The diplomatic incident was resolved. The road remained, and the story of the place where a US missile had gone wrong, where radios had failed, where compasses had drifted, began its long, slow journey through Mexican journalism, regional folklore, UFO circles, and eventually international media. By the late 1970s, the Zona del Silencio had a name and a reputation, and the name had come, at least in part, from what the recovery team had reported. That in this place, signals went quiet. Whether the silence is literal or metaphorical, total or partial, geological or something else entirely, is a question that researchers have been trying to answer ever since. The missile incident gave the zone its first serious outside witnesses, people with credentials, with equipment, with a documented reason to be there, and those witnesses came back with reports that were strange enough to take seriously and vague enough to leave room for imagination. That combination, credible strangeness with interpretive ambiguity, is exactly what a legend needs to take root and grow. The Athena missile story is, in many ways, the cleanest and most verifiable piece of the entire Zona del Silencio narrative. It has dates, a serial number, a launch facility, a diplomatic record, a physical road that still exists. Everything that comes after it, the UFO sightings, the albino animals, the strange lights, the accounts of visitors whose phones go dark, is harder to pin down, more dependent on individual testimony, more subject to the distortions that come with time and repetition and expectation. But the missile is a fixed point. It happened. It landed here. And in landing here, it opened a door that has never quite been closed. What the recovery team found when they entered the Bolson de Mapimí was, among other things, a landscape that does something very particular to people who are not used to it. The silence of the Chihuahuan desert at that latitude and elevation is not the silence of an empty room. It is a full, dimensional silence, the kind that has weight and direction, and a quality that is difficult to describe without resorting to the word vast. The flat basin floor stretches out in every direction, and the sky above it is enormous, and there is very little between those two surfaces to interrupt the eye or the ear. In that environment, a radio that crackles has a different quality than a radio that crackles in a city. A compass that drifts feels more significant when you are 50 kilometers from the nearest paved road. The desert amplifies unease the way a quiet room amplifies a dripping tap. That is not a supernatural property. It is a human one. But it matters because the people who first reported strange things here were not in a laboratory. They were in a desert, far from help, with malfunctioning equipment, and the landscape itself was doing what the Chihuahuan Desert does to everyone who spends time in it, making the ordinary feel slightly uncertain. That quality of the place, the way it sits on the edge of unsettling without ever quite tipping over into it, is something that runs through every account of the zone, from the 1970 recovery team to the researchers who came later to the tourists who come now. It is worth keeping in mind as we look more closely at what the land is actually made of, because the geology of the Bolson de Mapimí is not background detail. It is, in a real and measurable sense, the source of some of what gets reported here. The soil, the minerals, the rock formations, the closed basin structure, the particular way this landscape holds and deflects certain kinds of energy, All of that turns out to be directly relevant to the question of whether the zone's strangeness has a physical explanation. And the answer, when you look at the geology carefully, is more interesting than either the believers or the skeptics usually suggest. The Bolson de Mapimí is, at its most basic, a closed basin. That phrase, closed basin, sounds simple, but it has significant consequences for how water, minerals, and energy behave in a landscape. In most river systems, water falls as rain, collects, flows downhill, and eventually reaches the sea. In a closed basin, there is no exit. Water flows in from the surrounding slopes and the occasional flash flood, spreads across the flat floor, and then simply stops. It evaporates. It soaks into the ground. It does not leave. Over thousands of years, this process concentrates whatever the water carries, minerals, salts, metallic compounds, on and just below the surface of the basin floor. The flat, pale stretches of ground you see in photographs of the zone are not just dry dirt. They are the accumulated residue of centuries of evaporation, a slow chemical deposit left behind by water that arrived and never departed. The basin sits at roughly 1,100 metres above sea level, which is high enough to give the nights a genuine chill even in summer, when the daytime temperatures can push past 40 degrees. The elevation also affects atmospheric pressure and the behaviour of radio waves, which we will come back to. The surrounding landscape is not entirely flat. There are low ranges nearby, including the Sierra Oscura to the north, which translates, fittingly enough, as the Dark Mountains. These ranges are not dramatic by Mexican standards, not the soaring volcanic peaks of the south, but they are enough to define the basin's edges and to channel weather systems in ways that affect the microclimate of the floor below. The vegetation on the basin floor is sparse and low. Lechuguilla is one of the dominant plants, a stiff, spiky agave relative that grows in dense clusters and has a talent for puncturing boots and tyres with equal enthusiasm. Creosote bush covers large areas, giving the desert that particular sharp, resinous smell that people either find deeply pleasant or deeply strange, and which seems to intensify after rain. There are grasses, scattered and dry-looking, occasional stands of sotol, which is a tall plant with a crown of long serrated leaves that catches the light in certain ways. The landscape is not lush, but it is not barren either. It has the particular kind of life that desert environments develop when left alone long enough, which is careful, patient, and surprisingly varied if you look closely. The Reserva de la Biosfera Mapimí was established in 1979, which gives you some sense of how seriously the Mexican government took the region's ecological value even before the zone's reputation had fully developed internationally. The Biosphere Reserve covers roughly 342,000 hectares, which is a substantial area, and it was designated in part because of the genuinely unusual species assemblage found here, including the Bolson tortoise, which we will discuss in more detail later. The reserve designation also means that access to certain parts of the zone is regulated, which is worth knowing if you plan to visit. The desert looks open and unguarded, but there are rules, and they exist for good reasons. Now the geology. This is where things become directly relevant to the question of electromagnetic interference, and it is worth moving through it carefully. The soils and rock layers of the Bolson de Mapimí contain elevated concentrations of magnetite. Magnetite is an iron oxide mineral. Its chemical formula is Fe3O4, and it is one of the most magnetic naturally occurring substances on Earth. It was, in fact, the first magnetic material that humans ever identified and used, which is why lodestones, the naturally magnetized chunks of magnetite that ancient navigators used as primitive compasses, have such a long history. Magnetite forms in a range of geological environments, but it is particularly common in areas with a history of volcanic or hydrothermal activity, where iron-rich fluids have moved through rock and precipitated out over time. The Chihuahuan Desert region has that kind of geological history. It sits within a broader zone of tectonic activity associated with the Rio Grande Rift, a system of faults and basin structures that runs from Colorado down through New Mexico and into northern Mexico. When magnetite is present in high concentrations in soil and rock, it can do several things that are relevant to what people report in the zone. First, it can cause compass deviation. A standard magnetic compass responds to the Earth's magnetic field, but if there is a local source of magnetic material in the ground beneath you, the compass needle will be pulled toward that source instead of, or in addition to, magnetic north. The deviation can be subtle, a few degrees, or in areas of particularly high concentration, it can be dramatic enough to make a compass essentially useless. The reports from the 1970 missile recovery team about compass irregularities are consistent with this. They were not imagining it. Magnetite-rich ground genuinely does that. Second, magnetite and other iron-bearing minerals can absorb and scatter certain radio frequencies. This is not a simple or perfectly predictable effect. It depends on the specific mineral composition, the depth and distribution of the deposits, the frequency of the signal, atmospheric conditions, and a range of other variables. But the basic physics is real. Iron-bearing rock can act as a partial attenuator for electromagnetic radiation in certain frequency ranges, particularly the lower AM frequencies that were the standard for portable radio equipment in the 1970s. A radio that worked perfectly in Tabalos might crackle and fade in the basin, not because of any mysterious force, but because the ground between the transmitter and receiver was absorbing part of the signal. This is sometimes described in geological literature as a natural analogue of the Faraday cage effect, though that comparison is approximate rather than precise, and it is worth being careful not to overstate it. A true Faraday cage completely blocks electromagnetic signals. The geological effect here is more like a lossy absorber. It weakens signals, particularly at certain frequencies, without eliminating them entirely. What this means in practical terms is that the radio interference reported in the zone has a plausible physical basis. It is not necessarily uniform across the entire area. The mineral deposits are not evenly distributed, and the interference would vary depending on exactly where you are standing, what frequency you are using, and what the atmospheric conditions were doing. This patchiness is actually consistent with what people report. Visitors do not universally experience radio failure. Some do not. Some notice compass drift, others do not. That variability makes more sense if the effect is geological and localized rather than zone-wide and absolute. There is also an atmospheric dimension. The flat basin floor creates specific conditions for radio wave propagation that are different from what you would find in a city or a forested landscape. Under certain atmospheric conditions, particularly when there is a strong temperature inversion, which is common in desert basins, where the ground cools rapidly after sunset and creates a layer of cool air trapped beneath warmer air above, radio waves can be ducted along the inversion layer, travelling much farther than expected, or alternatively being trapped and scattered in ways that produce unexpected interference patterns. This is a well-understood phenomenon in atmospheric physics. It affects radio reception in deserts and coastal areas around the world. In the Bolson de Mapimí, with its combination of magnetite-rich soil and frequent temperature inversions, you have two separate mechanisms that can both affect radio behaviour, sometimes simultaneously. Now, there is one more geological feature of this region that deserves mention, and it is one of the most extraordinary things about the broader Chihuahuan desert geology, even if it is not located in the zone itself. About 200 kilometers to the north, near the town of Nica in Chihuahua, lies the Cave of Crystals, the Cueva de los Cristales, a cave that was discovered by miners in the year 2000 and contains some of the largest natural crystals ever found on Earth. Selenite crystals, a form of gypsum growing up to 11 meters long and weighing as much as 55 tons. The cave sits roughly 300 meters underground, flooded with mineral-rich water at temperatures around 50 degrees Celsius, and the crystals grew over hundreds of thousands of years in those conditions. The reason this matters for the zone is that the Nika Cave is part of the same broad geological system, the same basin and range structure, the same mineral-rich hydrothermal history, the same deep deposits of gypsum and selenite that underlie much of the Chihuahuan Desert. The zone's flat playa surfaces contain selenite crystals too, though nothing approaching the scale of Nika, small, pale, translucent fragments that catch the light when you look closely at the desert floor. They are a reminder that the ground here is not ordinary dirt. It is a complex mineral environment with a deep geological history, and only a fraction of what is beneath the surface has been mapped or studied in detail. All of this, the magnetite, the closed basin, the mineral concentrations, the atmospheric ducting, the selenite, adds up to a landscape that is genuinely unusual in ways that have nothing to do with the supernatural. The zone is strange because the geology is strange, and the geology is strange because of a long, specific history of tectonic activity, hydrothermal mineralization, and desert evaporation that has been building for millions of years. That is not a disappointing explanation. It is, if anything, more interesting than the alternative, because it means the place is doing something real and measurable, not just serving as a backdrop for human projection. That said, geology explains some of the zone's reported phenomena more cleanly than others. Compass deviation and AM radio interference have straightforward physical mechanisms, but the zone's reputation extends well beyond compass needles and crackling radios. There are accounts of GPS devices behaving oddly, though it is worth noting that modern satellite-based GPS signals operate at frequencies that are largely unaffected by magnetite absorption, which complicates some of the older claims when they are applied uncritically to modern technology. There are accounts of car engines cutting out, which is harder to explain geologically and has not been systematically documented. And then there are the lights, the encounters, the biological anomalies, the sense of presence that some visitors describe, none of which the magnetite content of the soil can account for directly. What the geology does, perhaps more than anything else, is create the conditions for a particular kind of human experience. When your compass drifts and your radio crackles and the silence of the basin presses in around you and the sky is enormous above you and you are 50 kilometers from the nearest town, you are primed to notice things. You are alert in a way that you would not be in a familiar environment. Your pattern recognition is running at a higher level. The same light on the horizon that you would dismiss at home becomes significant here. The same sound that you would ignore in a city demands attention in this silence. The geology creates real anomalies, and the real anomalies create a heightened state of awareness, and the heightened state of awareness makes everything else in the environment feel charged with possible meaning. That is not a criticism of the people who have reported strange things here. It is a description of how human perception works in unusual environments. The desert is doing something to you, and some of what it is doing is measurable, and some of what it is doing is happening entirely inside your own nervous system, and in the Bolson de Mapimí those two things are very difficult to separate. The researchers who have studied the area, and there have been genuine researchers from UNAM and other institutions who have taken the zone seriously as a scientific subject, have generally found that the electromagnetic anomalies are real but modest. Measurable compass deviations, yes. Localized radio interference, yes. A persistent zone-wide blackout that affects all frequencies and all equipment without exception, no. The zone is not a dead zone in any absolute technical sense. It is a zone of elevated and variable interference, which is a less dramatic description, but a more accurate one. What those researchers have also found, and what tends to get less attention in the popular accounts, is that the zone's geology raises genuinely interesting scientific questions that go beyond the folklore. The distribution of magnetite deposits in the basin floor, the precise relationship between the mineral concentrations and the measured magnetic anomalies, the way the closed basin structure affects local atmospheric conditions and their interaction with radio propagation. These are questions with real scientific value, independent of any mystery narrative. the zone deserves serious study not because it is haunted or anomalous in some inexplicable way, but because it is a complex and unusual geological environment that has not been fully characterized. The mystery, such as it is partly a mystery of incomplete data. And then there is the matter of what has fallen from the sky above this basin, because the zone's geological strangeness is matched, and in some ways exceeded by its relationship with space. The Bolson de Mapimí has an unusually well-documented history of meteorite impacts and recoveries, and that history begins with one of the most scientifically important events in modern meteoritics, which happened just 1 year before the missile incident, close enough in time that it is easy to wonder whether the coincidence shaped the way people interpreted everything that came after. So let us stay with the radio silence for a moment longer, because it is the claim that sits at the centre of everything else, the one that gave the zone its name, and the one that is most worth examining carefully before we move on to the stranger reports. The name itself, Zona del Silencio, does not refer to acoustic silence, though the desert is genuinely quiet in a way that surprises people who have not spent time in flat, open scrubland. It refers specifically to radio silence. The claim, in its most basic form, is that radio transmissions fail inside this stretch of desert. Signals that should carry for hundreds of kilometers weaken, distort, and disappear. Compasses spin or deviate. Electronic equipment behaves unpredictably. And the implication, repeated in magazine articles and television documentaries since the 1970s, is that something about this particular patch of ground is actively hostile to electromagnetic signals. That is a striking claim. And like most striking claims, it contains a real core surrounded by a considerable amount of elaboration. The real core is this. The soil and rock of the Bolson de Mapimí contain elevated concentrations of magnetite, iron oxide in its most magnetically active form. Magnetite is not unusual in desert environments, but the concentrations here are higher than average, and the closed basin structure of the Bolson means that mineral-rich sediments have been accumulating in the same place for a very long time without being flushed out by drainage. The result is a landscape where the ground itself has measurable magnetic properties. Not dramatic, not like standing next to an industrial magnet, but measurable. A compass held close to certain rock formations or soil deposits in the zone will deviate from magnetic north. The deviation is real and repeatable. Now, magnetite does not simply deflect compass needles. It also interacts with electromagnetic radiation at certain frequencies. Iron-bearing minerals can absorb and scatter radio waves, particularly in the AM and shortwave bands, which operate at lower frequencies and longer wavelengths than FEM or satellite signals. The mechanism is not unlike what happens when you drive through a tunnel or under a concrete overpass and your AM radio crackles and drops out. The material around you is absorbing and reflecting the signal. In the zone, the material doing this is not concrete but magnetite-rich soil and rock, distributed across a wide area rather than concentrated in a single structure. The effect is diffuse and variable rather than sharp and consistent, which is why some visitors notice interference and others do not, and why the interference tends to be worse in certain spots than others. There is also an atmospheric dimension to this, which is less often discussed in the popular accounts. The Bolson de Mapimí is a closed basin sitting at roughly 1,100 metres elevation, surrounded by low ranges that influence local air circulation. Under the right conditions, typically in the evening or early morning, when temperature gradients between the basin floor and the surrounding air are pronounced, the basin can develop what atmospheric physicists call ducting. This is a phenomenon where radio signals, instead of propagating outward and upward in a normal dispersal pattern, become trapped in a layer of air and travel along it in unexpected ways. Ducting can cause signals to travel much farther than they should, appearing at receivers hundreds of kilometers away. It can also cause signals to be absorbed into the duct layer and effectively disappear from receivers at ground level within the duct zone. The flat, enclosed geometry of the Bolson makes it well suited to this kind of atmospheric behaviour, and it is possible, not certain, but possible, that ducting contributes to the inconsistent radio behaviour that people report in the zone. Taken together, the magnetite absorption and the atmospheric ducting give you a plausible physical framework for at least some of the radio interference claims. Not all of them, and not consistently, but enough to explain why the phenomenon is real without requiring anything exotic. What complicates the picture is the question of which signals are actually affected. The original reports from the 1970s, the recovery team after the missile incident, the PEMEX survey workers, the early researchers, were all dealing with AM radio and shortwave communications. These frequencies are genuinely susceptible to the mechanisms described above. But as the zone's reputation grew through the 1980s and 1990s, the claims expanded. People began reporting that GPS devices failed, that satellite phones cut out, that modern digital equipment behaved strangely. And this is where the scientific picture becomes more complicated. Because GPS and satellite communication systems operate at frequencies between roughly 1.2 and 1.6 GHz, frequencies far higher than AM or shortwave, and much less susceptible to magnetite absorption. A magnetite deposit that reliably disrupts an AM signal at 1 MHz would have essentially no effect on a GPS signal at 1.2 GHz. The physics simply do not scale that way. This does not mean that GPS devices never malfunction in the zone. Electronic devices malfunction everywhere, for all kinds of reasons. But it does mean that when someone reports their GPS failing in the Mapimí Desert and attributes it to the zone's electromagnetic properties, that attribution is not well supported by the known mechanisms. It is more likely that the device had a software glitch, a battery issue, or simply lost satellite lock temporarily. Things that happen to GPS devices all over the world every day, but which feel significant in a place that has already primed you to expect electronic strangeness. UNAM researchers from the Universidad Nacional Autónoma de México, which has conducted fieldwork in the zone across several decades, have been fairly consistent on this point. The electromagnetic anomalies are real and measurable, but they are modest and frequency specific. The zone is not a dead zone in any absolute sense. There is no invisible dome over the desert that blocks all signals. What there is, more accurately, is a variable and patchy interference environment, stronger in some locations than others, more pronounced at some frequencies than others, and more noticeable under certain atmospheric conditions than others. That is a genuinely interesting finding. It is just not the same as a place where all electronics fail. One researcher's account from the late 1980s described taking a portable AM radio into the zone and walking a transect across the basin floor, noting where the signal from a Chihuahua station faded and recovered. The pattern was not uniform. There were pockets, stretches of maybe 100 meters or so, where the signal dropped significantly, followed by areas where it came back clearly. The researcher mapped these pockets against soil sample data taken at the same locations and found a rough correlation with higher magnetite concentrations. It was not perfect. The correlation was suggestive rather than definitive, but it was the kind of finding that pointed toward a physical explanation rather than a mysterious one. The zone has spots, not a blanket. This is worth sitting with for a moment, because it changes the character of the phenomenon. A zone-wide radio blackout is one kind of thing: dramatic, inexplicable, demanding explanation. Patchy interference correlated with mineral deposits is something else entirely. It is still unusual, it is still worth studying, but it is the kind of thing that geology and atmospheric physics can approach systematically, and the kind of thing that loses some of its drama when you understand the mechanism. And yet the zone's reputation is not built on modest patchy AM interference. It is built on something that feels much larger than that. Part of the reason is the 27th parallel claim, which deserves a brief mention here even though it belongs more properly to a later part of the story. The idea, circulated widely since at least the 1970s, is that the zone sits on approximately the same latitude as the Bermuda Triangle, the Egyptian pyramids, the Tibetan plateau, and several other sites associated with anomalous phenomena. The implication is that there is something special about this latitude band, some planetary or cosmic property that concentrates strangeness along it. The zone is listed at roughly 26.7 degrees north latitude, which is close enough to 27 degrees to be cited as confirmation. What this claim does not account for is that the latitude band between 25 and 30 degrees north covers an enormous fraction of the Earth's surface. It includes not just the Bermuda Triangle and the Mapimí Desert, but also most of Florida, the Sahara Desert, the Arabian Peninsula, northern India, southern China, and the Gulf of Mexico. Selecting 3 or 4 famous anomalies from this band and ignoring the thousands of entirely ordinary places at the same latitude is a textbook example of confirmation bias, the human tendency to notice and remember the examples that fit a pattern and quietly discard the ones that do not. The 27th parallel is not a line of cosmic significance. It is a line on a map, and lines on maps do not cause things to happen. That said, and this is worth noting because it is genuinely interesting, the subtropical latitude band around 25 to 30 degrees north does have real atmospheric significance. This is the zone where the Hadley cell, the large atmospheric circulation system that drives tropical weather, descends back toward the surface after rising at the equator. The descending air is dry, which is why most of the world's great deserts, the Sahara, the Arabian Desert, the Chihuahuan Desert, are clustered in this latitude band. The descending air also creates stable, high-pressure conditions that affect radio propagation and ionospheric behaviour. So there is a real atmospheric story at this latitude, just not the mystical one that the 27th parallel theorists are telling. The desert itself, and the specific atmospheric conditions that create it, are part of why the Bolson de Mapimí behaves the way it does. The latitude matters, but it matters through physics, not through numerology. What is perhaps most honest to say about the radio silence phenomenon is that it is a real effect that has been genuinely amplified by the conditions under which it is experienced. When you're standing in the Bolson de Mapimí, 50 kilometers from the nearest town, in a flat basin where the horizon is a clean line in every direction, where the silence is the kind that has weight, and your AM radio starts to crackle and fade, the experience is not neutral. You're not in a laboratory. You're in a place that already feels unusual, and the failing radio confirms something you were already half expecting. The environment and the expectation work together, and the result is an experience that feels much more significant than a modest magnetite-induced signal attenuation would produce in a more ordinary setting. That is not a dismissal of the people who have reported strange things here. It is an acknowledgement that human experience is always shaped by context, and the context of the Zona del Silencio is one of the most carefully constructed contexts in the folklore of the American Southwest. The name came first, or very nearly first, and the name told people what to look for. Once you're looking for silence, you find it. Once you're listening for the crackle of a failing radio, you hear it. The zone is partly a geological phenomenon and partly a perceptual one, and the two are so thoroughly intertwined by now that separating them cleanly may not be possible. What is possible is to ask what else the zone has offered up over the years, beyond the radio interference, beyond the compass deviations, beyond the atmospheric ducting and the magnetite deposits. Because the electromagnetic story, interesting as it is only one layer of what has made this place famous. There is another layer that arrives from above, not from satellites, but from much farther away, from deep in the solar system in fact, and it began falling into this basin long before anyone thought to give the place a name. The layer that arrives from above, as it turns out, has a very specific and documented history in this part of the world. The Mapimí region is one of the most meteorite-rich areas in the Western Hemisphere, and that is not legend or local mythology. It is a fact supported by decades of scientific recovery work and laboratory analysis. The desert floor of the Bolson de Mapimí has given up space rocks that have changed what we understand about the early solar system, and the most important of them arrived just 1 year before the missile incident that first brought the zone to national attention. On the morning of February 8th, 1969, at around 1 in the morning local time, a fireball streaked across the sky over the state of Chihuahua. People in towns and villages across a wide area saw it, a bright moving light that broke apart as it descended, scattering material across a large ellipse of scrubland near the small community of Pueblito de Allende, in the municipality of Allende, roughly 200 kilometers northeast of the Zona del Silencio. The sound of the impact was heard across several municipalities. By morning, fragments were scattered across an area estimated at roughly 50 kilometers long and 10 kilometers wide. Farmers and local residents began finding pieces in their fields almost immediately. What they had found was the Allende meteorite, and it turned out to be one of the most scientifically significant rocks ever recovered from the surface of the Earth. The total recovered mass exceeded 2,000 kilograms by some estimates, with fragments ranging from tiny chips to pieces weighing several kilograms. The material was collected by researchers from institutions across Mexico, the United States, and Europe over the following weeks and months. The timing was fortunate in a way that seems almost too convenient. NASA was preparing for the Apollo lunar sample return missions, and laboratories around the world had just upgraded their equipment and protocols for analysing extraterrestrial materials. The Allende meteorite arrived, in effect, just as science was ready for it. What the analysis revealed was remarkable. Allende is classified as a carbonaceous chondrite, one of the most primitive types of meteorite, meaning it preserves material from the very earliest period of the solar system before the planets had fully formed. Inside the meteorite, researchers found structures called calcium aluminum-rich inclusions, or CAEs. These small, irregularly shaped objects, typically a few millimeters to a centimeter across, are among the oldest solid materials ever identified. Their age has been measured at approximately 4.567 billion years, making them older than the Earth, older than the Sun as a stable star, and among the first solid objects to condense out of the solar nebula. They are, in a very literal sense, pieces of the beginning. The CAEs from Allende have been studied continuously since 1969, and they have contributed to our understanding of nucleosynthesis, isotopic anomalies, and the conditions that existed in the early solar system. Research papers citing Allende meteorite samples continue to be published today, more than 50 years after the fall. It is not an exaggeration to say that a single night in the Chihuahuan Desert in February 1969 handed science a library about the origin of the solar system. Now, Allende fell near Pueblito de Allende, not in the Zona del Silencio proper. The distance between the fall site and the zone's centre is roughly 200 kilometres. That is not a small distance. But in the geography of the legend, the distinction has blurred considerably over the years. The Allende meteorite is frequently cited in discussions of the zone as evidence of the region's unusual relationship with space, and the proximity, at a regional rather than local scale, has been enough to fold it into the zone's mythology. This is worth being clear about. The Allende meteorite did not fall inside the Zona del Silencio, as it is typically defined. But it did fall in the same broad geological province, the same desert landscape, the same Chihuahuan basin system, and just 1 year before the missile incident that gave the zone its name. The reason meteorites are found so frequently in this region is not, as the mythology sometimes implies, because the Bolson de Mapimí is some kind of cosmic target. The real explanation is more straightforward and, in its own way, more interesting. The terrain is nearly ideal for meteorite preservation and recovery. The flat, dry lake beds of the Bolson, the playas, are light-coloured and relatively featureless. A dark rock sitting on a pale, flat surface is easy to spot. The extreme aridity of the region means that meteorites weather very slowly once they land. In wetter climates, iron-bearing meteorites oxidize and crumble within decades. In the Chihuahuan Desert, they can survive for thousands of years with relatively little degradation. The low vegetation density means fewer places for fragments to hide. All of this adds up to a landscape that is, from a meteoritic standpoint, a natural collection tray. Researchers working in the broader Chihuahuan Desert region have recovered meteorites ranging from small iron fragments to larger stony chondrites, and systematic surveys in the area have continued to turn up new specimens. The Mapimí region specifically has yielded several named meteorites in the scientific catalogue, with finds documented from the late 19th century onward. The combination of flat terrain, minimal vegetation, slow weathering, and light-coloured substrate makes the entire basin system one of the better natural meteorite hunting grounds in the Americas. This is worth pausing on for a moment because it reframes something. The high concentration of meteorites in this region is not evidence of unusual cosmic activity over the Bolson de Mapimí. It is evidence of unusual preservation and visibility conditions on the ground. The sky above the zone is not more trafficked by space rocks than the sky above any comparable area. The desert floor is simply better at keeping what falls on it, and better at showing it to anyone who looks. The meteorites were always falling everywhere. Here they stayed, and here they were found. But the distinction between cosmic targeting and geological preservation is not one that translates well into a legend. A legend needs the zone to be special. It needs the sky to be drawn to this particular patch of desert, not just the soil to be good at keeping what the sky drops. And so the meteorite history has been absorbed into the zone's mythology in a way that suggests the Bolson de Mapimí is a place where the boundary between Earth and space is somehow thinner, where objects from the cosmos arrive with unusual frequency, where the desert floor is littered with messages from beyond the solar system. The Allende meteorite becomes not a chance event explained by orbital mechanics and desert preservation, but a sign. This is how mythology works, and it is not entirely dishonest. The Allende meteorite is genuinely extraordinary. The CAs inside it really are older than the Earth. The fact that they were sitting in a Mexican desert for billions of years before a farmer found them the morning after a fireball is genuinely strange to contemplate, even if the strangeness is entirely natural. The desert really does hold things that fell from space. The stone really does contain the oldest material you're ever likely to stand near. The mythology takes these true and extraordinary facts and gives them a frame. The zone, the silence, the cosmic significance, that makes them feel like part of a pattern rather than isolated wonders. And the frame is seductive because the desert itself encourages it. When you're standing in the Bolson de Mapimí on a clear night, the sky is something else entirely. There is almost no light pollution. The Milky Way is not a faint smear, but a dense textured band that takes up a significant portion of the visible sky. The stars are bright enough to cast faint shadows on the pale desert floor. In those conditions, the idea that rocks fall from that sky and land in this specific basin does not feel like coincidence. It feels like correspondence. It feels like the desert and the cosmos are in some kind of conversation that you're only dimly aware of. That feeling is not scientific evidence of anything, but it is a real human response to a real place, and it is part of why the zone's mythology has the texture it does. It is not built on nothing. It is built on genuine strangeness that has been given a particular interpretation, and the interpretation has stuck because the underlying facts are strange enough to support it. The meteorite connection also feeds directly into the zone's extraterrestrial mythology in a more specific way. Meteorites, in popular imagination, are associated with space, and space is associated with the possibility of other intelligences. The logical chain is loose. A rock from the asteroid belt is not a message from an alien civilization, but the association is persistent. Once the Allende meteorite and the other recovered specimens became part of the zone's story, the question of extraterrestrial visitation was never far behind. If rocks from space fall here, why not other things? If the sky sends material to this basin, why not visitors? The meteorites gave the zone's UFO mythology a kind of geological grounding, a physical precedent for the idea that this place has a relationship with what lies beyond the atmosphere. It is worth noting that the scientific value of the Allende meteorite and the other Chihuahuan specimens is entirely real and entirely independent of any mythology. Researchers at UNAM, at the Smithsonian Institution, at the Max Planck Institute, and at dozens of other institutions have worked with this material for decades. The zone's scientific reputation in meteoritics is legitimate. The flat desert basin is a genuine resource for planetary science, and that is not a small thing. The same terrain that generates UFO tourism also preserves materials that have helped scientists understand how the solar system formed. Both things are true at the same time, and they do not cancel each other out. What they do, together, is give the zone a kind of layered strangeness that is harder to dismiss than a single anomaly. The radio interference is one thing, the missile incident is another, the meteorites are a third. Each one, taken alone, has an explanation that is more or less satisfying, but experienced together, in a place that already has a name and a reputation, they accumulate into something that feels larger than any individual explanation. The zone becomes a place where unusual things happen, not because any single unusual thing is inexplicable, but because the unusual things keep arriving from different directions. The missile from New Mexico, the meteorites from the asteroid belt, the radiostatic from the magnetite-rich soil, the silence from the desert itself. And then, of course, there are the lights. Because the zone's mythology does not stop at rocks and radio waves. It extends into the night sky above the basin, into accounts of moving lights and hovering objects and encounters that have been described by people who were not looking for anything unusual when they found it. The meteorite history provides a kind of backstory for these reports, a context in which the sky above the Bolson de Mapimí is already established as a place where things arrive unexpectedly. The lights, whatever they are, inherit that context. They arrive into a story that has already been told, and the story shapes how they are understood. So let us talk about the lights. The reports of unusual lights in the Mapimí Desert are not a recent invention, and they are not the product of a single dramatic incident. They have accumulated slowly over decades, passed between ranchers and field workers and visiting researchers, described in ways that are often similar enough to suggest a shared phenomenon, even if no one can agree on what that phenomenon actually is. The most common description is an orange or white light, sometimes a single point, sometimes 2 or 3 together, moving low over the desert floor at night. Not streaking across the sky the way a meteor does, not blinking in a pattern the way an aircraft does, moving slowly, sometimes hovering, sometimes changing direction in a way that does not match anything with an obvious engine. Local ranchers in the Bolson de Mapimí have been describing lights like this for as long as anyone has been asking. The terrain makes verification difficult. The desert basin is vast and flat, and a light seen at 2 kilometers can look very different from a light seen at 20. Distances are hard to judge at night over featureless ground. A vehicle's headlights on a distant dirt track can behave strangely when refracted across warm air rising from the desert floor, appearing to hover, split, or vanish and reappear. Atmospheric plasma and ball lightning are real phenomena, rare but documented, capable of producing glowing, floating light sources that move in ways that seem deliberate, but are driven entirely by electromagnetic and atmospheric conditions. The Chihuahuan Desert, with its specific combination of heat, mineral-rich soil, and dry air, is not an implausible environment for these effects. These are the practical explanations, and they are worth taking seriously. But the thing about the Mapimí light reports is that they have persisted long enough and arrived from enough different sources that dismissing all of them as misidentified vehicles or atmospheric quirks requires a certain confidence that the evidence does not quite support. The workers from Pemex, the Mexican National Oil Company, who were conducting petroleum surveys in the region during the 1960s and 1970s, reported lights over the basin that they could not account for. These were not people looking for UFOs, they were engineers and technicians doing practical work in a remote location and they mentioned the lights the way you mentioned something that bothered you, something that did not fit the expected pattern of the night. The most specific and widely cited encounter involves a couple named Ernesto and Josefina Diaz, who were travelling through the Mapimí Desert in the 1970s when they reportedly encountered two individuals standing near the road. The account, as it has been retold across Mexican publications and later in international UFO literature, describes the two figures as unusually tall, with fair skin and light-coloured hair, an appearance that stood out sharply in the context of the northern Mexican desert. The Diaz couple reportedly stopped and spoke with them. The figures asked in Spanish for water. When Ernesto and Josefina asked where they were from, the response was, in the version that has been most widely repeated, something along the lines of "from above." The figures then left, and the couple drove on, shaken. Now, it is worth being careful here. This account has been retold many times, in many publications with varying details. The version you encounter depends heavily on which source you read and how many times the story has been filtered through other writers. The core elements, two unusual-looking strangers, a request for water, the phrase "from above," appear consistently enough that something was clearly reported. Whether the encounter was genuinely inexplicable, or whether it involved two ordinary people who happened to look unusual and gave an ambiguous answer to an ambiguous question, is impossible to determine from the available evidence. But the account has become one of the zone's defining stories, repeated in nearly every treatment of the place, and it has a texture that is harder to wave away than a smudged photograph of a distant light. What makes the Diaz account interesting in the context of the zone's broader mythology is not necessarily its supernatural content, but the way it fits the pattern of the place. The zone is not a site of dramatic, violent encounters. The lights do not attack, the strangers do not threaten, the compasses spin but no one is harmed. The radio goes quiet but the silence is not dangerous. The zone's mythology is strangely gentle for something that carries such an ominous name. The strangeness it offers is more unsettling than frightening. A persistent low-level sense that the ordinary rules are not quite applying, that the desert has its own logic and you are not fully privy to it. By the early 1980s, this quality had made the zone a destination. People began travelling to the Bolsón de Mapimí specifically to experience it, arriving in trucks and vans through Ceballos, the small town in Durango that sits roughly 50 kilometres from the zone's centre. Ceballos has a population of around 3,000 people, and it is not a large or prosperous place. But the zone gave it something that most small desert towns do not have, a reason for outsiders to come. Guides began offering trips out to the desert. Small restaurants and guest houses developed a sideline in zone tourism. The road that the US military had constructed in 1970 during the Athena missile recovery became the main access route, a rough dirt track cutting across the scrubland that, in a quietly ironic way, owes its existence to the most documented and unambiguous strange event in the zone's history. The tourism that developed was eclectic. Serious researchers came, geologists, electromagnetic engineers, biologists associated with the Mapimí Biosphere Reserve. UFO enthusiasts came with cameras and recording equipment. Journalists came to write features for Mexican magazines and later for international publications. Curious travellers came simply because the name was compelling and the landscape was unlike anything they had seen. The zone attracted a particular kind of visitor, someone drawn to places where the ordinary world seems to have loosened its grip slightly, where the familiar categories of explanation feel slightly less reliable than usual. This mix of visitors created something interesting. The zone became a place where reported experiences were shaped, at least in part, by expectation. Someone who arrives believing that the zone suppresses radio signals will interpret their phone's spotty reception as confirmation. Someone who arrives knowing the stories of lights will scan the night horizon with particular attention, and the human visual system presented with a dark, featureless landscape and a strong expectation is not always a reliable instrument. This is not a criticism of the people who reported experiences. It is simply an observation about how places with established reputations interact with the people who seek them out. The zone became, over time, a self-reinforcing phenomenon. Each visitor who reported something unusual added to the legend, which brought more visitors, which generated more reports. Some of those reports, it should be said, are genuinely hard to account for. The lights seen by Pemex workers who had no particular interest in UFOs. The compass anomalies reported by the US military recovery team in 1970. People who were there to do a practical job and had no incentive to embellish. The recurring descriptions of orange lights from ranchers who have spent decades in the desert and know its normal behaviour well. These accounts do not come from people who are primed to find something unusual. They come from people who found something unusual and then tried to describe it. What those lights actually are remains genuinely open. The atmospheric plasma explanation covers some cases. Vehicle lights and refraction cover others. Ball lightning, though rare, is a real and documented phenomenon that can produce exactly the kind of slow-moving, hovering glow that witnesses describe. The magnetite-rich soil may contribute to localized electromagnetic conditions that affect how light behaves near the surface. None of these explanations is entirely satisfying across all the reported cases, which is part of why the zone retains its reputation, even among people who are skeptical of supernatural explanations. There is also the simple fact that the Chihuahuan Desert at night is a genuinely strange environment, even without anything anomalous occurring. The darkness is total in a way that most people in the modern world rarely experience. The silence is deep enough to have a physical quality, not the absence of sound so much as the presence of quiet, which is a different thing. The sky, without light pollution, is overwhelming. The flat horizon in every direction gives the landscape a quality that is hard to describe, something between exposure and infinity. In those conditions, the human nervous system does things it does not normally do. Sounds seem louder, distances seem uncertain. The ordinary sense of being anchored in a familiar world loosens slightly. The zone's atmosphere, the genuine atmosphere of the place, the desert itself, creates conditions in which unusual experiences are more likely, not because the desert is supernatural, but because it is extreme. The lights, whatever their origin, arrive into that atmosphere. They are seen by people whose senses are already operating in an unfamiliar register, in a place that already has a name and a history. The zone does not need to be supernatural to generate experiences that feel that way. It needs only to be what it is: remote, silent, mineralogically unusual, historically layered, and genuinely dark in a way that modern life almost never is. What the lights have done, over 50 years of reports, is give the zone's mythology its emotional centre. The missile incident is dramatic but historical. The meteorites are scientifically fascinating but cold. The radio interference is technically interesting but not viscerally compelling. The lights are different. The lights are something you see. They are present in the moment, moving through the actual night sky above the actual desert, and they do not resolve into a clean explanation when you look at them. They stay strange. And that strangeness, immediate, visual, shared across multiple witnesses over multiple decades, is what gives the zone its particular hold on the imagination. By the time the zone's reputation had solidified in the 1980s and 1990s, the lights had become inseparable from the place itself. You could not talk about the Mapimí Silent Zone without talking about the lights, any more than you could talk about it without mentioning the missile or the silence. They had become part of the landscape, as much as the Lechugilla and the dry lake beds and the flat pale horizon. The zone had accumulated a mythology that was dense enough and layered enough that it could sustain serious attention, not just from UFO enthusiasts, but from anyone curious about what happens when a remote and genuinely unusual place acquires a name and a reputation and begins to attract the kind of human attention that shapes what gets noticed and what gets reported. And yet, beneath all of that, beneath the lights and the legends and the decades of accumulated stories, the desert itself remains. The balsan tortoises move slowly through the scrubland. The magnetite sits in the soil. The dry lake beds catch the starlight. The silence, which was there long before anyone gave it a name, continues. The zone's strangeness is real, even if its explanation is still being worked out. And the human stories that have gathered around it are real too, in their own way. Real as accounts of experience, real as evidence of how people respond to places that refuse to be entirely ordinary. The lights are part of that story. So are the people who saw them, and the people who came looking for them, and the small town of Kebalos that grew a modest economy around the possibility that something unusual might be happening 50 kilometers out in the desert. All of it together, the geology, the history, the encounters, the tourism, the mythology, forms a picture of a place that is genuinely difficult to categorize. Not haunted exactly, not a hoax, not fully explained, just strange, persistently and specifically strange, in ways that keep generating questions. But the zone's strangeness does not end with the sky. The desert floor itself has its own peculiarities. In the plants, the animals, the biology of a place where the soil is saturated with minerals and the silence is deep enough to feel inhabited. Because some of the most unusual claims about the Mapimí Silent Zone are not about lights or missiles or radio waves at all. They are about the living things that have been found here and what the desert may have done to them over a very long time. The balsan tortoise is not an animal that demands your attention. It moves slowly, eats slowly, and has spent roughly 8 million years refining the art of patience in exactly this kind of landscape. Flat, dry, mineral-rich, and indifferent to urgency. Gopherus flavomarginatus, to give it its full name, can grow to around 45 centimeters in length, which makes it one of the largest land tortoises in North America. It spends most of its life underground in burrows that can stretch several meters deep, emerging in the cooler parts of the day to graze on whatever sparse vegetation the desert offers, and it is found in any meaningful population almost nowhere else on Earth. The Balsan de Mapimí and the surrounding desert basin is essentially its last stronghold. That alone makes the biology of this place worth paying attention to, entirely apart from anything else the zone is known for. The Mapimí Biosphere Reserve was established in 1979, and one of the primary reasons for its creation was the protection of exactly this tortoise. The reserve covers roughly 340,000 hectares, which is a very large piece of desert, and it was set aside because scientists recognized that the ecosystem here, unusual, isolated and under increasing pressure from grazing and development, was worth preserving before it disappeared. The tortoise was listed as endangered, and the Biosphere Reserve gave it a formal layer of protection. Researchers working within the reserve have been studying the population for decades, tracking individual animals, monitoring nesting behavior, and trying to understand how a species this specialized survives in an environment this demanding. The work is quiet, methodical, and has nothing to do with UFOs or radio silence. It is just careful biology in an unusual place. But the zone's mythology has not left the biology alone. Over the years, a persistent thread in the stories told about Mapimí involves animals that seem somehow different from their counterparts elsewhere. The most frequently cited claim is the white rattlesnake, an albino or leucistic specimen reportedly seen by ranchers and visitors in the area. Albinism does occur in rattlesnakes. It is rare, but it is a documented genetic variation, and in a population that is geographically isolated, rare traits can persist and even concentrate over generations in ways that would not happen in a more connected population. The Chihuahuan Desert has several rattlesnake species, and occasional pale or whitish specimens have been reported across the broader region, not only in the zone. So the claim is not impossible. Whether the zone specifically has a higher rate of such variation than surrounding areas is a different question, and the honest answer is that no systematic survey has been done to confirm it. Pale-coloured rabbits have also been mentioned in accounts going back to the 1970s. The desert cottontail and the black-tailed jackrabbit are both common in the region, and both can show lighter coloration in populations that have been isolated for long periods. The flat, pale terrain of the Bolson creates a specific kind of selective pressure. Animals that are lighter may be harder to spot against the dry lake beds and sandy soil, which could favour lighter coloration over generations. This is basic natural selection, not mutation in the alarming sense. It is the same logic that explains why Arctic foxes are white, and why the peppered moth famously changed colour in industrial England. The zone's geology and terrain are unusual enough that they could plausibly shape the appearance of animals living there over long periods of time without any supernatural mechanism being required. The claim about unusually large cacti and tortoises is a bit harder to evaluate. The Bolson tortoise does grow large, but that is simply what the species does. It is not a mutation, it is the animal's natural size. Visitors who are not familiar with it might find it unexpectedly impressive, which could feed into the narrative of the zone producing oversized creatures. The Chihuahuan Desert also supports some genuinely large cacti, including the opuntia and various columnar species, and in areas with specific soil chemistry and water availability, individual plants can grow to notable sizes. Whether the zone produces plants that are measurably larger than similar species elsewhere in the desert is, again, something that would require careful comparative study to confirm, and that study has not been done in a way that supports the stronger version of the claim. What the Biosphere Reserve's scientific team has consistently said in the accounts that are available is that they have not found evidence of systematic mutation rates above what would be expected in any isolated desert population. The biology here is unusual, but it is unusual in ways that have straightforward ecological explanations. Geographic isolation tends to produce genetic differentiation over time. Specific soil chemistry affects what plants can grow and how they grow. Mineral concentrations in water sources influence the physiology of animals that drink from them. None of this requires the zone to be doing something supernatural to the living things inside it. It requires only that the zone is genuinely isolated, genuinely mineralogically distinct, and genuinely old as an ecosystem. The mineral question is worth staying with for a moment, because it connects the biology of the place to the geology in a way that is more interesting than the mutation stories. The soil in the Bolson de Mapimí contains elevated concentrations of magnetite, iron oxide, and other metallic compounds. These are not just interesting for their electromagnetic properties, they also enter the food chain. Plants absorb minerals from the soil through their root systems, and the specific mineral profile of the soil shapes what those plants contain. Animals that eat those plants absorb those minerals in turn. Animals that drink from water sources percolating through mineral-rich rock absorb them directly. Over generations, a population living in a mineralogically unusual environment will have a different physiological baseline than a population of the same species living in ordinary desert soil 50 kilometers away. This is not a dramatic effect, and it is not the kind of thing that produces visible monsters or glowing animals. But it is real, and it is the kind of subtle influence that could, over enough generations, affect coloration, size, behaviour, and reproductive patterns in ways that a careful observer might notice even if they could not immediately explain them. There is also the question of what the silence itself does to the biology of the place. This sounds like a metaphor, but it is not entirely one. Noise pollution is now recognised as a genuine ecological stressor. Animals in noisy environments, near roads, near industrial sites, near human settlements, show measurable differences in behaviour, stress hormone levels, and reproductive success compared to animals in quiet environments. The Bolson de Mapimí is one of the quietest large landscapes in North America. The Biosphere Reserve protects it from most industrial noise. The nearest significant human settlement is Ceballos, 50 kilometers away. In the interior of the zone, the ambient sound level is low enough that a person standing still can hear their own heartbeat. Animals living in that environment for generations have evolved in conditions of genuine acoustic quiet, which may contribute to behavioural differences that visitors find striking without being able to name exactly why. The Lechuguilla is worth mentioning here because it is one of the most characteristic plants of the zone and one of the most physically striking. Lechuguilla is a type of agave with long, rigid, sharply pointed leaves that grow in dense rosettes from the desert floor. It is not a large plant. The rosette typically sits low to the ground, but it is incredibly dense and sharp. Walking through a field of Lechuguilla in the dark is genuinely dangerous. The leaves can puncture leather boots. They have been known to injure horses badly enough to cause permanent lameness. The plant blooms once in its lifetime, sending up a tall flowering stalk that can reach 4 or 5 meters, then dies. The desert floor in much of the zone is covered with these plants, interspersed with creosote bushes and sparse grasses, and the overall effect is a landscape that looks simultaneously beautiful and inhospitable in a very specific way. The pale soil, the sharp plants, the flat horizon, the silence. It creates a visual texture that is unlike most desert landscapes, and it contributes to the zone's atmosphere in a way that is entirely natural and entirely real. The creosote bush is the other dominant plant, and it has its own quiet strangeness. Creosote is one of the oldest living plants on Earth. Individual clones in the Mojave Desert have been estimated at over 11,000 years old, which means they were already ancient when the first human settlements were appearing in Mesopotamia. The creosote in the Bolson de Mapimí is not as well studied as those in the Mojave, but the species is the same and the longevity is the same. These plants have been growing in this desert for longer than most human civilizations have existed. They release a distinctive resinous scent after rain. The smell that most people associate with the desert, that sharp, clean, almost medicinal smell. And in the zone, where rain is rare and the soil chemistry is unusual, the scent has a particular quality that visitors frequently comment on. It is one of those sensory details that makes the place feel different without being able to explain exactly why. The Biosphere Reserve itself is a genuine scientific asset, and it is worth being clear about that. The researchers who work there are not studying the zone's mythology. They are studying the Chihuahuan Desert ecosystem in one of its most intact remaining forms. They monitor the Bolson tortoise population. They track plant diversity. They study the hydrology of the closed basin, the way water moves through the playas, the way the dry lake beds fill and evaporate, the way the aquifer beneath the basin responds to drought and rain. They are doing the patient, unglamorous work of understanding a complex ecosystem before it changes. The zone's reputation as a place of strangeness has, in a roundabout way, helped protect the Biosphere Reserve by keeping it in the public conversation and making it difficult for development interests to dismiss the area as worthless desert. The mythology and the science have a complicated relationship here, but they have not been entirely at odds. What the biology of the zone adds to the overall picture is a kind of grounding. The lights in the sky are dramatic and hard to explain. The missile incident is historically vivid. The radio interference is technically interesting. But the biology is quietly, persistently real in a way that does not require any special pleading. The Bolson tortoise is genuinely rare. The Lechuguilla fields are genuinely striking. The mineral-rich soil genuinely influences the living things inside it. The silence is genuinely deep. These are not anomalies in the supernatural sense. They are the characteristics of a place that has been shaped over millions of years by specific geological and climatic conditions into something that is simply unlike most other places on Earth. The zone does not need to be haunted to be unusual. It needs only to be itself. And yet the unusual biology, or at least the stories about it, has fed into the zone's mythology in much the same way that the lights and the radio interference have. The white rattlesnake becomes evidence of mutation. The large tortoise becomes evidence of something in the soil. The strange plants become part of the landscape of strangeness. The zone absorbs all of it, the real and the exaggerated, the documented and the anecdotal. and incorporates it into a single narrative about a place where the ordinary rules seem to bend. That narrative has a specific history and specific architects, people who shaped it, promoted it, and sent it out into the wider world in ways that made the zone famous far beyond the Chihuahuan Desert. Because the biology is strange enough on its own, and the geology is strange enough on its own, and the lights are strange enough on its own. But none of those things became a legend by themselves. The legend required someone to build it, and the story of how that happened is, in its own way, as interesting as anything the desert itself has produced. The man most responsible for turning the Mapimí Silent Zone into a nationally recognized mystery was a Mexican journalist and researcher named Harry de la Peña. He began writing about the area in the mid-1970s, and his work had a particular quality that made it effective. He took the existing fragments of strangeness, the missile incident, the radio interference reports, the meteorite history, the light sightings, and he wove them together into a single coherent narrative. Not a dishonest one, necessarily. He was not fabricating events. But he was doing what good storytellers do, which is finding the shape that was already latent in the material and drawing it out clearly so that other people could see it too. The shape he found was the shape of a mystery zone, a place where the normal rules of physics and communication seemed to loosen, a place that had drawn a missile across the sky from New Mexico, a place where rocks fell from space, a place where lights moved at night and radios went quiet. He gave that shape a name, and the name stuck. The Mexican magazine Contenido ran features on the zone in the late 1970s that reached a large national readership. Impacto, another widely read Mexican publication, followed with its own coverage. These were not fringe publications. They were mainstream magazines, the kind that sat on kitchen tables and in waiting rooms, the kind that people read on buses and passed to their neighbours. The stories they ran were written with the tone of serious inquiry. Careful, curious, not hysterical, which made them more persuasive, not less. They presented the missile incident as documented fact, which it was. They presented the meteorite history as scientifically significant, which it also was. And then they extended those facts into a broader framework of anomaly, drawing connections between the radio interference, the lights, and the geological strangeness in a way that felt logical if you followed the argument and did not stop to pull it apart. The comparison to the Bermuda Triangle appeared almost immediately, and it was effective because it gave Mexican readers a reference point they already understood. The Bermuda Triangle was at the height of its cultural prominence in the 1970s. Charles Berlitz had published his best-selling book on the subject in 1974, and it had sold millions of copies worldwide. The idea of a zone where the normal rules did not apply, where ships and planes and signals disappeared, was deeply familiar to popular audiences. The Mapimí Silent Zone slotted neatly into that framework. It was Mexico's Bermuda Triangle. It was in the same latitude band, more or less. It had its own disappearing signals and its own inexplicable incident. The comparison was not scientifically rigorous, but it was culturally powerful, and it travelled far. By the early 1980s, the zone had been featured in international publications. American and European magazines picked up the story, usually citing the Mexican sources, usually adding their own layer of atmospheric detail. The version that circulated internationally was somewhat more dramatic than the original reporting. The radio blackout was described as total rather than intermittent. The compass deviation was described as dramatic rather than modest. The missile's deviation was described as impossible rather than simply unusual. Each retelling added a little more certainty to the claims and smoothed away a little more of the ambiguity. This is how legends work. The rough edges get worn smooth in transit. What is interesting about this process is that it was not entirely separate from the real history of the place. The Pemex surveys are worth discussing here, because they are part of the story in a way that often gets overlooked. Pemex, the Mexican state oil company, conducted petroleum exploration surveys in the Chihuahuan Desert region during the 1960s and into the 1970s. The Bolson de Mapimí and the surrounding areas were assessed for hydrocarbon potential, which required sending survey teams into remote terrain with radio equipment, seismic instruments, and various electronic tools. Some of those workers reported radio interference in the area. Some reported compass irregularities. These were practical, workman-like reports, the kind of observations that a field engineer writes in a survey log because it is relevant to operations, not because he is trying to create a mystery. The equipment was not working reliably in certain areas. That was a real operational fact. But when those reports entered the public narrative, they were transformed. The Pemex worker who noted radio interference in a field log became evidence of a persistent zone-wide phenomenon. The survey team that had compass trouble in one particular stretch of terrain became evidence that the entire zone was electromagnetically anomalous. The practical language of engineering reports does not survive well in popular storytelling. It gets translated into something more vivid, and in that translation, the specifics, the localized nature of the interference, the particular equipment involved, the specific conditions, tend to disappear, leaving only the dramatic core. The town of Ceballos, Durango played its own role in all of this. Ceballos sits roughly 50 kilometers from the zone's center, and it became the primary gateway for visitors who wanted to experience the place for themselves. The town had existed for decades as a small agricultural and ranching community, the kind of place that does not appear on many maps and does not expect to appear on many maps. The zone's growing reputation changed that. By the mid-1980s, Ceballos had developed a modest tourism economy built almost entirely around the Silent Zone. Local guides offered trips into the desert. Small businesses sold maps, guides, and souvenirs. The community had a genuine economic interest in the zone's continued fame, which meant that the stories were sustained and retold and kept alive in ways they might not have been otherwise. This is not a criticism of Ceballos. Small communities in remote regions have few options for economic development, and the zone's reputation was a genuine asset. But it did mean that the local storytelling ecosystem was oriented toward maintaining and amplifying the mystery, rather than examining it critically. A guide who tells visitors that the zone is genuinely strange and inexplicable is a more effective guide than one who explains the electromagnetic properties of a magnetite and the limitations of 1970s radio technology. The experience that visitors came looking for was the experience of genuine strangeness, and the local infrastructure shaped itself around providing that experience. There is something self-reinforcing about this dynamic that is worth sitting with for a moment. When people arrive at a place expecting unusual experiences, they are more likely to notice and report unusual experiences. This is not deception. It is how human perception works. If you walk into a desert expecting your phone to behave oddly, you will notice every small fluctuation in signal strength that you would normally ignore. If you drive down a remote dirt road expecting your compass to spin, you will watch your compass more carefully than you ever have before and interpret any deviation as confirmation. The zone generated a steady stream of visitor reports of anomalous experiences, and those reports fed back into the legend, which attracted more visitors who generated more reports. The cycle was efficient and largely self-sustaining. Harry de la Peña continued writing about the zone for years, and his work evolved as the legend grew. He incorporated new reports as they came in, new sightings, new accounts of electronic malfunction, new stories from locals and visitors. He was, in a sense, the zone's unofficial archivist, the person who kept track of the accumulating record and periodically synthesized it into updated narratives. His role is comparable to the role that certain writers have played in other legendary places, the person who is not quite a scientist and not quite a fiction writer, but something in between, a chronicler of the anomalous who takes the raw material of reported experience and shapes it into something coherent and communicable. The magazine cycle of the late 1970s and early 1980s was particularly important. because it established the zone's canonical narrative, the version of the story that all subsequent tellings would reference and build upon. That canonical narrative had specific elements that became fixed: the missile that went off course, the radio silence, the strange lights, the meteorites, the unusual biology, and the latitude connection to the Bermuda Triangle. These elements were not all equally well documented, but they were all present in the canonical version, and subsequent tellings treated them with roughly equal weight. The missile incident, which was genuinely documented, and the alien visitors' account, which was a single anecdotal report, sat side by side in the narrative and acquired similar levels of apparent credibility simply by proximity. This flattening of evidential hierarchy is one of the most consistent features of Mystery Zone mythology. It happens in the Bermuda Triangle literature, in the accounts of Area 51, in the stories told about Skinwalker Ranch. The documented and the anecdotal are placed in the same frame and presented with the same narrative confidence, and the reader or listener absorbs them together without necessarily registering that some claims rest on solid ground and others rest on a single person's testimony from decades ago. The zone's canonical narrative did this effectively, and it is part of why the legend has proved so durable. By the late 1980s, the zone had entered the international paranormal literature in a fairly stable form. It appeared in books about unexplained phenomena alongside entries on the Bermuda Triangle, the Nazca Lines, and the Tunguska Event. It was cited as evidence of mysterious latitude-based anomaly zones. It was referenced in UFO literature as a site of confirmed extraterrestrial activity, which it was not, but the Diaz account and the persistent light reports gave that claim enough surface plausibility to circulate. The zone had become, in the language of cultural studies, a site of convergent mythology, a place where multiple strands of anomalous belief had converged and reinforced each other until the whole was considerably more impressive than any of the individual parts. What is genuinely interesting about this process, when you look at it from a certain angle, is that it did not require anyone to lie. The missile incident was real, the magnetite was real, the meteorites were real, the lights, whatever they were, had been seen by multiple people. The radio interference had been reported by practical engineers with no interest in creating a legend. The Bolson tortoise was genuinely rare and genuinely large. Every brick in the edifice was at minimum a real brick. The architecture that those bricks were assembled into was not scientifically rigorous, but the materials were not fabricated. The zone's legend was built from real things, arranged into a shape that the real things did not quite support, but which felt internally coherent and was culturally resonant in a specific historical moment. The 1970s were a particularly receptive moment for this kind of story. The Bermuda Triangle was at its cultural peak. Von Daniken's ancient astronaut books were bestsellers. Public interest in UFOs, paranormal phenomena, and unexplained mysteries was higher than it had been in decades. The zone arrived at precisely the right cultural moment, with precisely the right combination of documented incidents and atmospheric strangeness, and it found an audience that was already primed to receive it. Harry de la Peña and the magazines that ran his work were not creating demand. They were meeting demand that already existed. The zone's reputation has softened somewhat since its peak in the 1980s. It is no longer front-page news in Mexican magazines. The UFO tourism wave has subsided into something quieter and more niche. The Bermuda Triangle has been largely debunked in the popular press, which has taken some of the air out of the latitude-based anomaly narrative. But the zone has not disappeared from public consciousness. It remains well known in Mexico, particularly in the northern states. It continues to attract visitors. The guides in Ceballos still lead trips into the desert. The stories are still told. The canonical narrative is still available in books and websites and YouTube videos and late-night conversations in the towns along the Chihuahuan desert edge. And the zone itself, the actual desert, the actual soil with its magnetite and its iron oxide, the actual playas and lechuguilla fields and dry lake beds, has not changed. The geology that generated the original interference reports is still there. The atmospheric conditions that create unusual radio propagation are still there. The bolson tortoises are still moving slowly across the pale desert floor. The silence is still real. The legend was built from real materials, and the real materials have not gone anywhere. They have simply been waiting, as they have always waited, for someone to come out and look at them carefully and try to understand what they actually are, rather than what the stories say they are. That examination, the actual scientific work of trying to understand the zone on its own physical terms, is a different kind of story from the one the magazines told. It is quieter, more qualified, and in some ways more interesting, because it does not require the zone to be impossible in order to be genuinely unusual. The science that has been done here, and the science that has not yet been done but probably should be, is where the zone's story becomes something other than mythology. The scientific work that has actually been carried out in the Mapimí Silent Zone is not as dramatic as the legend, but it is not nothing either. That distinction matters, because one of the easier rhetorical moves when examining a place like this is to say that science has looked and found nothing. Case closed, mystery dissolved. That is not quite accurate. What science has found is more nuanced than that, and more interesting in its own quiet way. The most systematic early investigations came from researchers associated with UNNAM, the Universidad Nacional Autónoma de México, which conducted electromagnetic surveys in the region during the 1970s and into the 1980s. These were not enormous funded expeditions with large teams and years of fieldwork. They were more modest than that. Survey teams going into the desert with instruments, taking measurements across different locations within the basin, recording what they found. The conditions for fieldwork in the Bolson de Mapimí are not comfortable. The heat alone is a logistical challenge. Summer temperatures regularly exceed 40 degrees Celsius, and the terrain is rough enough that reaching specific measurement sites requires significant effort. But the surveys were done, and they produced data. What that data showed was, broadly speaking, this. The soil in parts of the zone does contain elevated concentrations of magnetite and iron oxide. These are not trace amounts. In certain areas, the measurements indicated concentrations high enough to produce localized magnetic anomalies, places where a compass needle would deviate measurably from magnetic north. The deviation was not dramatic in most cases. We're not talking about a compass spinning freely like a broken toy. We are talking about deviations of a few degrees, sometimes more in specific spots, but generally modest in scale. Enough to cause confusion if you are navigating carefully and trusting your compass without awareness of the local geology. Not enough to fully explain every interference report that has come out of the region, but enough to confirm that the underlying claim, that the ground here has unusual magnetic properties, is not invented. The Mexican government's Comisión Nacional de Zonas Áridas, known as CONAZA, has also done environmental assessments of the Bolson de Mapimí over the years, primarily focused on land use, water resources, and ecological conditions rather than electromagnetic phenomena. But their soil surveys have contributed to the broader picture of what the ground in this region actually contains. The mineral profile of the basin is genuinely unusual. The combination of magnetite, iron oxide, and other metallic compounds distributed through the soil and underlying rock layers creates a substrate that behaves differently from ordinary desert soil when it comes to electromagnetic propagation. This is not a claim that requires any exotic physics. It is basic geology and basic radio science sitting alongside each other. The radio interference question is worth spending some time on because it is the central claim of the zone, and it has a more complicated scientific picture than either the believers or the skeptics tend to acknowledge. The original interference reports came from practical people, Pemex engineers, military recovery teams, survey workers, who were not trying to create a legend. They reported that their radio equipment behaved unreliably in the area. Those reports are real. The question is what caused the unreliability, and whether it constitutes the kind of persistent zone-wide radio blackout that the legend describes. One important factor is atmospheric ducting. The flat basin of the Bolson de Mapimí creates specific atmospheric conditions, particularly in the temperature inversions that form over desert terrain at night and in the early morning. Under certain atmospheric conditions, radio signals behave in unexpected ways over flat terrain. They can travel much farther than their normal range, bouncing between the ground and an atmospheric layer above, which sometimes causes receivers to pick up distant signals instead of local ones, creating apparent interference. In other conditions, signals can be absorbed or scattered by the surface in ways that reduce their effective range. The flat, mineral-rich basin is particularly prone to these effects. This is a real atmospheric phenomenon, well documented in radio propagation science, and the Bolson de Mapimí's geography makes it a good candidate for experiencing it. What this means in practical terms is that the interference reports are not imaginary, but they are not evidence of a mysterious force either. A radio that works unreliably in the zone is probably experiencing a combination of magnetite-related signal absorption, atmospheric ducting effects, and the simple fact that the region is remote and far from transmission towers. The interference is real, its cause is physical and explainable. The experience of it, however, particularly for someone who was not expecting it and did not have a background in radio propagation science, would have felt genuinely strange. You're in a flat desert, the sky is clear, there is no obvious reason why your radio should not work, and it does not work. That experience is disorienting in a way that a technical explanation does not entirely dissolve, even after you've been given the explanation. The GPS question is worth addressing separately, because it complicates the older interference claims in an interesting way. Modern GPS and satellite-based navigation systems operate on frequencies that are largely unaffected by the magnetite concentrations in the soil. Visitors to the zone today who report that their GPS devices behave oddly are describing something different from what the Pemex engineers and military recovery teams experienced with their AM and shortwave radio equipment in the 1960s and 1970s. Some visitors do report GPS irregularities, but these are inconsistent. Many visitors notice nothing unusual at all with their devices. The original interference reports were specific to certain radio frequencies, and those frequencies are the ones most susceptible to the absorption and scattering effects that magnetite-rich soil produces. The zone does not appear to be a place where all electronic signals fail. It appears to be a place where certain older radio technologies, under certain atmospheric conditions, behave unreliably. That is a narrower and more precise claim than the legend suggests, but it is a more honest one. No systematic study has confirmed a persistent zone-wide radio blackout. That is the honest scientific summary. The interference is real but patchy. It occurs under specific conditions in specific locations within the basin. It can be explained by known physical mechanisms. It is not constant, it is not universal across all frequencies, and it is not evidence of an anomalous force that cannot be accounted for by standard physics. The zone is not electromagnetically dead. It is electromagnetically complicated in ways that are interesting to scientists and disorienting to unprepared visitors. There is one aspect of the zone's electromagnetic environment that has received less formal study than it deserves, and that is the interaction between the magnetite deposits and the specific atmospheric conditions that form over the basin during different seasons. The Bolson de Mapimí experiences significant variation between seasons, hot and dry in summer, cooler and occasionally wetter in winter, with dramatic temperature swings between day and night throughout the year. These variations affect the atmospheric layering above the basin, which in turn affects radio propagation. A comprehensive electromagnetic study that tracked signal behaviour across different seasons, different times of day, and different weather conditions would produce a much richer picture of what is actually happening here. As of the available record, that level of sustained systematic monitoring has not been done. This is not a criticism of the researchers who have worked in the area. Sustained atmospheric monitoring in a remote desert requires infrastructure, funding, and long-term institutional commitment, all of which are difficult to secure for a site that the scientific community does not regard as a priority. The zone is, in the eyes of most researchers, an interesting geological curiosity with a disproportionately large folkloric reputation. That assessment is probably correct, but it has also meant that the zone has not received the kind of careful, long-term scientific attention that would finally settle some of the outstanding questions about its electromagnetic behaviour. What would a rigorous modern study actually look like? This is a reasonable question to sit with for a moment, because the tools available today are considerably more capable than what the UNAM survey teams had in the 1970s and 1980s. Drone-based electromagnetic mapping could cover the basin systematically at low altitude, producing a detailed spatial map of magnetic field variations across the entire zone rather than the point measurements that earlier surveys relied on. This would show exactly where the anomalies are strongest, how they're distributed, and whether they correspond to known geological features. Soil core analysis at multiple locations could give a precise stratigraphic picture of the mineral concentrations at different depths, which would help explain whether the magnetic anomalies are surface phenomena or extend into the deeper rock layers. Long-term atmospheric monitoring stations placed at several points within the basin could track temperature inversions, humidity, and signal propagation conditions across seasons, building a dataset that would finally allow researchers to characterize the ducting effects with precision. None of this is technically difficult. It is simply a matter of whether anyone decides it is worth doing. There is also the question of the strange lights that have been reported over the basin for decades. Some of these have plausible explanations that sit within known atmospheric physics. Ball lightning, while still not fully understood, is a real phenomenon that has been documented in other desert environments. Atmospheric plasma phenomena, sometimes called earth lights or tectonic lights, have been proposed as explanations for luminous events near areas of geological stress and mineralization. The Bolson and Mapimí's unusual mineral profile makes it, in theory, a candidate for this kind of phenomenon. Whether it actually produces such events is not confirmed by any systematic study, but it is not an implausible hypothesis either. The honest position is that some of the light reports probably have conventional explanations: vehicle headlights refracted across the flat basin, atmospheric optical effects, misidentified aircraft, and some may involve phenomena that are not yet fully characterized by science. That is a less satisfying answer than either they are alien craft or they are all misidentifications, but it is probably the most accurate one available. What is clear from the scientific record is that the zone is genuinely unusual in several measurable ways. The magnetite concentrations are real and produce measurable compass deviations. The atmospheric conditions create real radio propagation anomalies. The meteorite concentration in the surrounding region is genuinely high by any comparative standard. The biology of the basin includes species, particularly the Bolson tortoise, that are rare and ecologically significant. These are not invented features. They're documented physical realities that give the zone a legitimate claim to being an unusual place, quite apart from any supernatural interpretation. The gap between what science has confirmed and what the legend claims is large, but it is worth being precise about where the gap actually lies. Science has not confirmed a mysterious force, an extraterrestrial presence, a persistent electromagnetic dead zone, or systematic biological mutations. Science has confirmed unusual mineral concentrations, localized magnetic anomalies, real but explainable radio interference, and genuine ecological rarity. The legend takes those real features and extends them far beyond what the evidence supports. But the real features are there, and they are worth knowing about on their own terms. There is something quietly satisfying about that picture if you allow yourself to sit with it. The zone does not need to be a portal to another dimension to be genuinely interesting. It does not need alien visitors or a mysterious force that defies physics. It is a closed desert basin with unusual geology, specific atmospheric behaviour, a remarkable fossil and meteorite record, rare endemic species, and a human history of interference reports that have real physical causes. That is already a more interesting place than most patches of desert on Earth. The legend added drama and extraterrestrial flourish, but the underlying reality was already doing something worth paying attention to. The scientific picture also leaves room for genuine uncertainty in a few places. The light reports have not been fully explained. The precise mechanism of the radio interference in all its reported forms has not been comprehensively characterized. The relationship between the mineral concentrations and the long-term health of the basin's flora and fauna has not been studied with the rigor it would deserve. These are real open questions, not supernatural mysteries, but they are open nonetheless. The zone is not a completely solved problem. It is a partially understood place where the known and the uncertain sit alongside each other in a way that honest science acknowledges without inflating. And perhaps that is the most useful frame for thinking about what the zone actually is. A place where real physical phenomena, modest in scale but genuine in nature, were encountered by people without the tools to explain them, were then mythologized by a cultural moment that was hungry for mystery and have since been partially but not fully explained by science that has looked at the question without quite committing to a thorough answer. The zone sits in that middle space. More than nothing, less than legend, genuinely worth understanding on its own physical terms. The science that has been done here confirms enough to take the place seriously. The science that has not yet been done suggests that the full picture is still waiting to be drawn. What the zone's electromagnetic story points toward, when you follow it carefully, is a broader question about this particular latitude and what the atmosphere above it actually does. Because the 27th parallel, it turns out, has some real atmospheric physics worth knowing about, and that is where the zone story takes an unexpected turn into something that is neither mythology nor simple geology, but the actual behaviour of the Earth's atmosphere at this particular band of the planet. So let us spend some time with the latitude claim, because it is one of the most persistent pieces of the zone's mythology, and it is also one of the most instructive examples of how a real fact can be stretched into something that sounds much more significant than it actually is. The basic claim goes something like this. The Mapimí Silent Zone sits at approximately 26.7 degrees north latitude. The Bermuda Triangle, that other great repository of disappearances and strange phenomena, sits at roughly 25 degrees north. The Egyptian pyramids at Giza sit at approximately 30 degrees north. The claim is that these three famous anomaly zones share a latitude band, and that this shared position is meaningful, that there is something about this particular strip of the planet that produces unusual effects, strange disappearances, compass failures, lost aircraft, and unexplained events. Some versions of the claim extend it further, adding the Tibetan Plateau, parts of the Himalayas, and other locations that fall somewhere in the same broad range. The implication is always the same. This latitude is special. Something runs through it. It is a compelling idea, if you do not look too carefully. The first thing worth noting is the precision problem. The Bermuda Triangle at 25 degrees north and the Mapimí Zone at 26.7 degrees north are roughly 190 kilometers apart in latitude terms. The Egyptian pyramids at 30 degrees north are about 370 kilometers further north again. That is not a single latitude. That is a band spanning more than 5 degrees of arc, which at this point on the globe represents a strip of Earth's surface roughly 550 kilometers wide from its southern edge to its northern edge. And that strip, when you wrap it all the way around the planet, covers an enormous amount of territory. It includes most of northern Mexico, the entire Gulf of Mexico, large parts of the American South, the Mediterranean coast, northern Africa, Saudi Arabia, southern Iran, northern India, southern China, and a significant portion of the Pacific and Atlantic Oceans. The claim that a handful of famous anomaly sites share this latitude band is a bit like saying that several famous restaurants share the same city. It sounds like a pattern until you realise the city in question has 12 million people and thousands of restaurants, and the ones you picked are simply the ones you already knew. This is confirmation bias in its cleanest form. You begin with a handful of famous anomalous places, note that they fall within a broad latitude range, and then announce the pattern. But you do not count the hundreds of places within the same latitude range where nothing unusual has been reported. You do not ask whether the anomaly rate in this band is actually higher than in other bands. You do not ask whether the band itself was defined by the locations of the anomalies, which would make the whole exercise circular. You simply find the pattern you were looking for, because you were looking for it. None of this is unique to the zone. It is a very human thing to do. Pattern recognition is one of the things our minds are genuinely good at, and it is also one of the ways our minds mislead us most reliably. We are extraordinarily sensitive to coincidence, and extraordinarily bad at evaluating whether a coincidence is meaningful. When two famous strange places share a latitude, it feels significant. When we learn that the latitude band between them contains hundreds of unremarkable places, the feeling fades, but it takes conscious effort to let it go. What is interesting, though, is that when you set the numerology aside and look at what the atmosphere actually does at this latitude, there is something genuinely worth knowing. The 27th parallel sits within what atmospheric scientists call the subtropical high-pressure belt. This is not a mysterious or exotic concept. It is one of the most fundamental features of the Earth's atmospheric circulation, and it shapes the climate of enormous portions of the planet in ways that are well understood and well documented. Here is the basic picture. The Earth's atmosphere circulates in large cells driven by the differential heating between the equator and the poles. Near the equator, warm air rises, moves toward the poles at high altitude, and then sinks back toward the surface at roughly 30 degrees north and south. This circulation pattern is called the Hadley cell, named after the 18th century meteorologist George Hadley, who first described it in 1735. The sinking air at around 30 degrees north creates a persistent zone of high atmospheric pressure. High pressure air is denser and tends to suppress cloud formation and precipitation. This is why the world's great deserts cluster near this latitude. The Sahara, the Arabian Desert, the Sonoran Desert, the Chihuahuan Desert where the zone sits, all of them owe their aridity in large part to the Hadley cell boundary and the descending air of the subtropical high. This is the real atmospheric physics of the 27th parallel, and it is actually more interesting than the numerological claim because it explains something concrete. The Mapimí Silent Zone is a desert because of where it sits in the global atmospheric circulation. The same mechanism that makes the Sahara dry makes the Bolson de Mapimí dry. The same descending air that creates the conditions for the Egyptian pyramids to survive for 4,000 years without being washed away by rain also creates the conditions that preserve meteorites on the desert floor of Chihuahua. The latitude is not magic. It is atmospheric mechanics operating at a planetary scale, but the Hadley cell boundary does more than create deserts. It also has specific effects on radio wave propagation and ionospheric behaviour, and this is where the atmospheric physics becomes relevant to the zone's actual electromagnetic story in a more direct way. The ionosphere is the upper layer of Earth's atmosphere, roughly 60 to 1,000 kilometres above the surface, where solar radiation ionizes gas molecules and creates a region of electrically charged particles. This layer reflects certain radio frequencies back toward the Earth's surface, which is why AM radio signals can travel enormous distances at night. They bounce between the ionosphere and the ground repeatedly, covering thousands of kilometres. The behaviour of the ionosphere is not uniform across the planet. It varies with latitude, time of day, season and solar activity, and the subtropical regions near 30 degrees north have specific ionospheric characteristics that differ from equatorial regions and mid-latitude regions. At the latitude of the zone, the ionosphere is influenced by the same atmospheric dynamics that create the subtropical high-pressure belt. The descending air of the Hadley cell creates conditions that affect the density and behaviour of the ionospheric layers above it. This can produce anomalies in radio signal propagation, conditions where signals are absorbed more strongly than expected, or where they travel in unexpected directions, or where the usual reflection patterns are disrupted. These effects are real and measurable. They are studied by radio engineers and atmospheric physicists precisely because they affect long-distance communication systems. None of this confirms that the zone has a unique and persistent radio blocking effect. The ionospheric behaviour at this latitude is variable, not constant, and it affects large regions, not a specific patch of desert. But it does mean that the zone's latitude is not entirely irrelevant to the electromagnetic story. The atmospheric and ionospheric conditions at 27 degrees north are genuinely different from those at, say, 50 degrees north or 10 degrees north, and those differences can, under certain conditions, contribute to the kinds of radio anomalies that have been reported in the Bolson de Mapimí. The honest synthesis is something like this. The latitude itself does not create a mysterious zone of silence, but it does create a set of atmospheric conditions: dry air, specific pressure dynamics, particular ionospheric behaviour, that, when combined with the local geology of the Bolson, produce a place where radio interference is more likely than in most other patches of desert. The zone is not special because of its latitude alone. It is somewhat unusual because of the combination of its latitude, its geology, its mineral content, its closed basin topography, and its specific atmospheric behaviour. Take any one of those factors away and the picture changes. Together, they produce something that is genuinely, if modestly, anomalous. It is also worth thinking about what the subtropical high-pressure belt means for the sky above the zone, because this has a practical consequence that feeds directly into the UFO and strange lights mythology. The same atmospheric conditions that suppress cloud formation and precipitation also create extraordinarily clear, dry air. The Bolson de Mapimí sits at 1,100 metres elevation, far from any major city, with almost no light pollution and some of the clearest, driest air in North America. On a clear night, the sky above the zone is extraordinary. The Milky Way is visible as a dense band. Planets are sharp and bright. Satellites pass overhead in clean arcs. Meteors, which are common in this region given its documented meteorite history, burn bright and long across the darkness. This matters because many of the strange lights reported over the zone are seen at night, in conditions of extreme atmospheric clarity, by people who may not be accustomed to how vivid and unusual a truly dark, clear desert sky can appear. A bright planet near the horizon, shimmering through the atmospheric haze, can look like a hovering light. A meteor burning across a flat landscape with no trees or buildings to provide scale can appear to move in ways that seem impossible. A satellite catching the last sunlight after sunset can appear as a steady, silent light, moving purposefully across the sky. None of this explains every report. Some of the light accounts are detailed and specific enough that simple, astronomical misidentification seems inadequate. But the atmospheric clarity of the zone, which is itself a consequence of its latitude and the Hadley cell dynamics, creates conditions where the sky is more vivid and more surprising than most people ever experience, and that vividness feeds the mythology. There is also something worth saying about the human experience of pattern at this latitude specifically. The world's great desert civilizations, Egyptian, Mesopotamian, Arabian, Mesoamerican in the northern reaches, all developed within or near this subtropical band, partly because the dry, clear conditions were good for astronomy, agriculture in certain forms, and the preservation of built structures. The same atmospheric clarity that makes the zone's night sky spectacular made the Egyptian desert a good place to observe the stars, and the same mineral-rich geology that gives the Bolson its magnetic anomalies gave Egyptian builders access to specific kinds of stone. The 27th parallel is not magic, but it is the latitude of a particular kind of landscape and a particular kind of sky. And humans have been finding meaning in both for a very long time. The claim that the zone, the Bermuda Triangle and the pyramids are connected by a shared latitude is not supported by any physical mechanism that science has identified. But the impulse behind the claim, the sense that this band of the planet is somehow distinctive, is not entirely without basis. It is a region of genuine atmospheric and geological character. The distinctiveness is real. The supernatural interpretation of it is not. What the latitude story really reveals is something about how the zone's mythology was built. It was built by taking real features, the geology, the electromagnetic interference, the meteorite history, the clear sky, the genuine isolation, and connecting them to other famous mysteries through loose geographical association. The Bermuda Triangle was the great mystery of the 1970s, the decade when the zone first became famous. Linking the zone to it by latitude was a way of borrowing credibility, of saying that this Mexican desert belongs in the same conversation as the most famous anomaly zone in the world. It was a rhetorical move, not a scientific one, but it worked, because the zone's real features were unusual enough that the connection felt plausible. And this is perhaps the most quietly interesting thing about the latitude claim. It did not need to be true to be effective. The zone was already strange enough. The missile had already crashed here. The meteorites had already fallen. The compass already deviated. The biosphere already harboured a tortoise found almost nowhere else on Earth. The sky was already remarkable. The silence was already real. None of that needed the Bermuda Triangle. None of it needed the pyramids. The zone had its own identity, its own physical character, its own legitimate strangeness. The latitude connection was added not because the place needed more mystery, but because the people writing about it wanted to give it a larger stage. What the atmosphere does at 27 degrees north is genuinely interesting. What the geology does in the Bolson de Mapimí is genuinely interesting. What the sky looks like above the zone on a clear winter night is, by any account, genuinely beautiful. None of those things require a connection to distant mysteries to be worth paying attention to. The zone stands on its own physical reality, which is strange and specific and real enough that it drew a military recovery team, a biosphere reserve designation, decades of scientific surveys, and an unbroken stream of curious visitors. That is not the achievement of numerology. That is the achievement of a place that is, on its own terms, unusual. And if you follow the zone story from the missile to the meteorites to the geology, to the biology to the atmospheric physics of the latitude, what you find is not a single mystery, but a layered one. Each layer real, each layer explainable to a degree, and each layer still carrying a small residue of the unresolved. That residue is not evidence of the supernatural. It is simply evidence that the zone has not yet been studied with the full attention it probably deserves. The science that has been done here is enough to take it seriously. The science that has not yet been done is enough to keep the questions open. Which brings the story naturally to the question of what it's actually like to stand in this place, to drive the old military road out of Caballos, to step out of a vehicle onto the pale desert floor, to feel the heat and the silence and the extraordinary sky, and to ask yourself what you're actually experiencing in a place that has carried this much human imagination for so long. The drive out to the zone begins in Ceballos, which is a small, quiet town in the state of Durango that most people in Mexico have never visited and most people outside Mexico have never heard of. It sits roughly 50 kilometers from the center of the zone, and it has the particular character of a place that exists mainly because the desert around it required people to be somewhere. The population is around 3,000. There is a gas station, a few small restaurants, some basic accommodation, and a community that has learned over the past few decades that curious strangers will keep arriving and will need something to eat and somewhere to sleep before heading out into the scrubland. The road from Ceballos toward the zone is the same road that was built in 1970 by the American military recovery team that came to retrieve the Athena missile. More than 50 years later, it is a rough dirt track. It has not been paved. It has not been significantly improved. It has been used enough that it is passable in a reasonably capable vehicle, but it is not the kind of road you drive quickly, and it is not the kind of road that rewards inattention. The desert on either side is flat and pale and extends to a horizon that seems farther away than it should. The lechugia plants grow low and sharp along the roadside. The creosote bushes are spread at intervals that look almost deliberate, as if someone arranged them. The sky above is enormous in a way that is hard to describe until you are actually under it. Summer temperatures in the zone reach 45 degrees Celsius. That is not unusual for the Chihuahuan Desert in July or August, but it is worth saying plainly because it is the kind of heat that changes how you think. It is the kind of heat where you become aware of your water bottle in a way that you are normally not. Visitors who come in summer often describe the experience as physically demanding in a way they did not fully anticipate, even if they knew the temperature in advance. The air is dry, which means the heat does not feel humid or oppressive in the way of tropical heat, but it is relentless. There is very little shade. The ground reflects warmth back upward. The light is intensely bright and flat, and by midday the landscape has a bleached, overexposed quality, as if the colour has been partially removed. Most experienced visitors and local guides recommend coming in spring or autumn, when the temperatures are more manageable and the desert takes on a different character. In October, the Bolson can be mild and even beautiful in an austere way. The ski are deep blue, the scrubland carrying its sparse greens and yellows, the silence genuine and not competed with by the sound of your own discomfort. There is a small visitor area near the centre of the zone marked with a modest sign. It is not elaborate. It is the kind of marker that acknowledges a place has been designated without making any particular claims about what that place is. Some visitors find this underwhelming after the long drive in. Others find it exactly right. A quiet acknowledgement in a quiet place. There are no gift shops at the marker. There are no interpretive panels with dramatic graphics. There is the sign, the flat desert, the sky, and whatever you brought with you. What people actually experience when they arrive varies considerably, and this variation is itself one of the more interesting things about visiting the zone. Some visitors report that their phones lose signal almost immediately after leaving Ceballos, which is not surprising given the remoteness, but which feels significant in the context of the zone's reputation. Some report GPS behaving oddly, freezing, recalculating, or showing incorrect positions for a period before correcting itself. Others report no unusual behaviour from their devices at all. A few visitors have described their compasses spinning or giving inconsistent readings in specific spots, while others have checked compasses throughout their visit and found them entirely normal. This inconsistency is actually consistent with what the science suggests. The electromagnetic anomalies in the zone where they exist are localized. They are not a uniform field covering the entire area. The magnetite deposits are concentrated in specific geological formations, and the magnetic deviation they produce is real but patchy. If you happen to stand directly over a significant deposit, you might get a measurable compass deviation. If you're standing 50 meters away, you might notice nothing at all. This means that visitors who report anomalies and visitors who report nothing are both telling the truth. They were simply in different spots, or arrived with different expectations, or paid different levels of attention to their instruments. The local guides who lead tours into the zone are an interesting group. Some of them are from Ceballos families who have been living near the zone for generations and have a practical, grounded relationship with the desert that is quite different from the UFO tourism framing. They know where the dry lake beds are, where the terrain gets soft, where the best views of the sky are at night. They know how to read the weather and how to manage visitors who underestimate the heat. Some of them are skeptical of the more dramatic claims about the zone and will say so directly if asked. Others lean into the mythology because it is what many visitors have come to hear, and because the tourism economy of Ceballos depends in part on the zone's reputation. There is a mix of visitor types that is itself worth noting. Serious researchers do come here. Geologists, botanists interested in the Biosphere Reserve, meteoriticists, and electromagnetic researchers who want to take their own measurements. UFO enthusiasts come in significant numbers, particularly in groups organised around the zone's reputation for strange lights, and they tend to arrive with night vision equipment, cameras, and a readiness to interpret anything unusual as confirmation of what they hope to find. Then there are the curious travellers, people who have read about the zone and simply want to see what it is like, who have no particular agenda and are open to whatever the desert offers. And there are the campers and hikers who come for the landscape itself, for the Biosphere Reserve's genuine ecological interest, for the night sky, and for the particular pleasure of being somewhere genuinely remote. The Biosphere Reserve has specific access rules designed to protect the ecosystem, particularly the balsam tortoise population. Visitors are not supposed to leave designated paths in certain areas, and vehicles are restricted to established tracks. This is not always followed, and the pressure of tourism on the reserve's more sensitive zones is a real concern for the scientists and conservationists who work there. The zone's fame has brought attention to a genuinely valuable ecosystem, but it has also brought foot traffic and disturbance that the reserve's management has to work to balance. At night, the zone becomes something else entirely. The absence of light pollution in the Bolson de Mapimí is extreme. There are no nearby cities large enough to wash out the sky. The flat terrain means the horizon is low and open in every direction. The altitude of around 1100 metres means the atmosphere above you is a little thinner, the stars a little sharper. On a clear night with no moon, the Milky Way is visible as a physical structure, not just a faint smear, but a band of actual depth, with dark lanes and bright clusters and a sense of dimension that is genuinely startling if you're not accustomed to truly dark skies. Many visitors describe the night sky as the most memorable part of the visit, more affecting than any electromagnetic anomaly or unusual compass reading. It is easy to understand, standing under that sky, how the light's reports accumulated over decades. The sky is so active, so full of moving points and shifting brightness, that the threshold for noticing something unusual is lower than it would be in a light-polluted environment. Satellites cross the sky regularly. Meteors appear with a frequency that surprises people who have only ever watched for them from cities. Aircraft crossing at high altitude catch the light in ways that can look strange. And then there are the atmospheric phenomena, the occasional low-lying light that moves across the desert floor, which some researchers attribute to ball lightning or piezoelectric discharge from the stressed rock layers below, and which others attribute to vehicle lights from distant tracks refracted across the flat basin. None of these explanations is fully satisfying for every specific report. Some of the light accounts from long-time residents of the region are detailed and consistent enough that they deserve more careful study than they have received. The genuine silence of the place is something that almost every visitor mentions, and it is worth taking seriously as a physical fact rather than just an atmospheric effect. The Bolson de Mapimí has very little ambient sound. There is no running water, there are no large animals moving through brush, there is no wind on calm nights, the desert insects are present but not loud. The result is a silence that has a quality to it, a texture almost, that is different from simply the absence of noise. It is a silence that you become aware of as a presence rather than an absence. People who spend a night in the zone often describe becoming acutely aware of their own breathing, their own heartbeat, the small sounds of their own body that are normally masked by the continuous low noise of inhabited environments. This is not supernatural. It is just genuinely quiet in a way that most people never experience, and the effect is real and memorable. Whether that silence is the same silence that gives the zone its name is a question worth asking. The name Zona del Silencio does not actually derive from the sensory experience of standing in the desert. It derives from the radio interference claims, from the idea that signals go silent here, that communication fails, that the zone swallows transmissions. but the experiential silence of the place reinforces the name in a way that makes it feel right, even if the etymology is different. You arrive expecting silence, and the desert provides it, not because it is blocking your radio, but because it is genuinely deeply quiet in the way that only very remote, very flat, very dry landscapes can be. The Mapimí Biosphere Reserve designation, which was established in 1979, has given the zone a layer of scientific legitimacy that sits alongside and sometimes in tension with its UFO reputation. The reserve was created because the region is genuinely ecologically important. The Bolson tortoise alone is reason enough. A species so restricted in its range and so vulnerable to disturbance that the reserve's protections are not symbolic but necessary. The reserve also contains plant communities and insect populations that have been studied by UNAM researchers and found to be more diverse than the harsh landscape might suggest. The Chihuahuan Desert is, contrary to its appearance, one of the more biodiverse desert systems in the world, and the Bolson de Mapimí is one of its more interesting corners. Visitors who come expecting a barren, featureless wasteland are often surprised by how much is actually present. The Lechuguilla is everywhere, its sharp points catching the light at certain angles and giving the desert floor a faintly crystalline quality. The creosote bushes, which can live for thousands of years through clonal reproduction, have a deep, resinous smell after rain that is one of the more distinctive scents in the natural world. The occasional dry lake bed, or playa, is a striking feature, a flat expanse of pale, cracked earth that looks almost artificial, like a floor that has been laid and then abandoned. After rare rain events, these playas can briefly hold water, and the transformation of the landscape when that happens is apparently dramatic, with birds arriving from distances that suggest they have been waiting for exactly this. The zone's infrastructure for visitors remains minimal, which is both a limitation and, depending on your perspective, a feature. There is no resort. There is no interpretive centre with multimedia displays. There is the dirt road, the marker, the desert and the sky. Ceballos provides the basics, and the local guides provide the context, but the zone itself makes no concessions to comfort or convenience. This is part of why the experience tends to be memorable, even for visitors who encounter no anomalies at all. The place demands a certain kind of attention simply because there is nothing else to attend to. The desert does not distract you. It holds you in place and asks you to look at it. Some visitors come back more than once. There are accounts of researchers who made their first trip out of curiosity and returned for more systematic work, drawn by specific questions about the electromagnetic properties of particular rock formations, or by the desire to spend more time under the sky, or simply because the zone stayed with them in a way that other places had not. The combination of physical strangeness and genuine remoteness creates a kind of pull that is hard to fully articulate, but that seems to operate on a significant number of people who make the drive out from Ceballos. The zone's reputation has also meant that it carries the weight of everything people bring to it. Visitors who arrive expecting confirmation of UFO activity tend to find things that feel confirmatory. Visitors who arrive as skeptics tend to find things that confirm their skepticism. The desert is large enough and strange enough to accommodate both. A compass deviation that one visitor finds thrilling, another dismisses as expected given the geology. A light on the horizon that one visitor films as evidence, another identifies as a vehicle on a distant track. The zone does not resolve these interpretations. It simply presents itself flat and hot and silent, and lets people decide what they're experiencing. This interpretive openness is not unique to the zone, but the zone has it in an unusually concentrated form because its reputation has been so carefully constructed over so many decades that it arrives before the visitor does. By the time you step out of a vehicle onto the pale desert floor, you have already been told what to expect. The silence, the interference, the lights, the strangeness. The desert then provides a canvas onto which those expectations can be projected. Whether what you find is what is actually there, or what you are prepared to find, is a question that the zone leaves genuinely open. What is not open is the physical reality of the place. The heat is real. The silence is real. The sky is real. The magnetic anomalies are real, if modest. The meteorites are real. The Bolson tortoises are real, moving slowly through the scrubland in the dark, carrying their extraordinary evolutionary history in their shells. The selenite crystals are real, somewhere beneath the desert floor, part of the same geological system that makes this basin unlike almost anywhere else on Earth. The military road is real, a line drawn across the desert by a recovery operation that nobody planned and nobody expected, which became the path that brought everyone who came after. All of that was here before the legend. All of it will be here after the legend fades, if it ever does. The zone's physical character is not dependent on its reputation. It is just the desert, doing what deserts do, preserving things, amplifying things, making the sky enormous and the silence complete, and sitting quietly at the edge of the known world while people make the long drive out to see what all the fuss is about. And when you have spent a night there, when you have watched the Milky Way cross the sky and felt the temperature drop sharply after sunset, and heard nothing at all for long enough that the silence becomes something you notice, rather than something you ignore, you start to understand why the place accumulated the stories it did. Not because the stories are true, necessarily, but because the place is the kind of place where stories feel possible, where the ordinary categories of explanation feel slightly less secure than they do at home, where the gap between what you know and what you're experiencing is just wide enough that something can slip through. That gap, and what people have chosen to fill it with over the past half-century, is really what the zone story's about. And so, we arrive at the question that the zone has always been quietly asking, beneath the missile stories and the compass deviations and the lights in the dark and the magazine features and the tourist markers and all the rest of it. What is this place, really? Not in the sense of what supernatural category it belongs to, but in the simpler, more honest sense of what it actually is when you strip away the half-century of accumulated mythology and look at the thing itself. What it is this. A closed desert basin in northern Mexico, sitting at roughly 26.7 degrees north latitude, where the soil contains elevated concentrations of magnetite and iron oxide, where the geology is unusual enough that localized compass deviations are measurable, where the flat terrain and dry air create atmospheric conditions that affect radio propagation in ways that are real but patchy and explainable. A place where, on the morning of July 11th, 1970, a United States Air Force test missile came down in the wrong country entirely, and a recovery team had to build a road through the scrubland to retrieve it, and that road became the path that everyone who followed them would use. A place where, on February 8th, 1969, one of the most scientifically important meteorites in human history fell from the sky about 200 kilometers to the south and scattered 300 kilograms of material older than the solar system across the desert floor. A place where the Bolson tortoise, Gopherus flavomarginatus, moves through the scrubland at its own unhurried pace, carrying a lineage that stretches back millions of years, unbothered by the human arguments about whether the desert it lives in is genuinely strange or only famously strange. All of that is real. None of it requires embellishment. The geology alone is worth a serious conversation. The meteorite history alone is extraordinary. The military incident alone is a genuinely odd chapter in Cold War logistics. The biology alone, the rare tortoise, the lechuguilla, the creosote that has been clonally alive for thousands of years, the brief dramatic flooding of the playas after rare rain, is worth the drive from Tabalos on its own terms. The zone does not need the UFO reports, or the tall fair-skinned strangers, or the mutation claims, or the Bermuda Triangle parallels to be interesting. It was already interesting before any of that arrived, but the mythology arrived anyway, and it arrived for reasons that are themselves worth understanding. Because the way a place becomes legendary is not random. It follows a kind of logic, even if that logic is more human than geological. The missile came down in 1970, and the recovery team reported radio interference, and that was a real event with real documentation. But the interference was probably related to the magnetite-rich soil and the atmospheric conditions of the basin, not to some zone-wide force field. The missile went off course because rocket guidance systems in 1970 were not what they are today, and the Chihuahuan Desert was simply where it landed. But the coincidence of landing here, in this particular stretch of desert with its particular mineral composition, was striking enough that people started asking whether it was really a coincidence. And once people start asking that question about a place, the place begins to accumulate answers, not because the answers are there, but because the question creates the conditions for finding them. Harry de la Peña wrote about it. The magazines ran the features. Pemex workers mentioned the radio interference they had noticed during petroleum surveys. Practical observations about a real phenomenon that got folded into a larger narrative about a zone of silence. The Bermuda Triangle was in the cultural air in the 1970s, a hugely popular mystery at the time, and the zone fit neatly alongside it. The comparison was made, the parallel was drawn, and the zone inherited a portion of the triangle's mythology along with its own. By the time visitors started making the drive out from Caballos in the 1980s, the story was already fully formed. The place had been named, the name had been explained, and the explanation had been illustrated with enough specific incidents that it felt documented rather than invented. This is how legends work. They are not usually fabricated from nothing. They are built from real events and real observations and real strangeness. And then those real foundations are extended, connected and amplified until the structure is larger than any individual fact within it. The zone's legend is built on real geology, a real missile, real meteorites, real interference, real lights in the desert sky. The structure built on top of those foundations is much larger than the foundations themselves. But the foundations are there, and that is part of why the story has lasted as long as it has. It is not easy to simply dismiss, because the kernel of genuine strangeness at its centre is real. What is also real is the human need that the zone has been serving for 50 years. There is something in people that wants there to be places like this, places where the ordinary rules feel less certain, places where the gap between the known and the unknown is narrow enough to peer through. The zone offers that. It offers it in a form that is accessible, that you can drive to from a small town in Durango, that you can stand in and feel and photograph and argue about with the person next to you. It is a container for a kind of wondering that does not have many other containers available. The desert holds the wondering without resolving it, which is exactly what wondering needs. There is something worth sitting with in that. The zone is, among other things, a place where people go to feel the edges of what they understand. Not everyone who makes the trip is a UFO enthusiast or a believer in the paranormal. Many visitors are simply curious people who have heard that there is a place in the Mexican desert where strange things happen and who want to know what strange feels like from the inside. What they find, most of them, is the desert, the heat, the silence, the enormous sky, the compass that may or may not behave oddly depending on exactly where they are standing, the horizon that extends farther than any horizon they have seen before, and sometimes, at night, lights that may be ball lightning or atmospheric plasma or distant vehicles or something they cannot immediately identify. The experience is rarely dramatic, but it is rarely nothing either. The zone has a way of making you pay attention, and paying attention in a place that is genuinely remote and genuinely strange is its own kind of experience, independent of whether anything supernatural is occurring. The selenite crystals are somewhere under the sand. Not directly underfoot, perhaps, but part of the same geological system, the same vast mineral story that the Bolsón de Mapimí has been writing for millions of years. The Cueva de los Cristales in Nica, 200 kilometers away, with its cathedral-sized chambers full of crystals that can be 12 meters long, is part of the same chapter. The basin is extraordinary in ways that have nothing to do with radio signals or missile trajectories. It is a place where the Earth has done something unusual with its materials, where the combination of mineral composition and closed basin hydrology and geological time has produced things that exist almost nowhere else. That is not a metaphor. That is just the geology, and the geology is remarkable. The Bolson tortoises are out there tonight, somewhere in the scrubland beyond the dirt road, moving in the dark at the pace that tortoises move, which is slow enough that the night feels very long around them. They have been in this desert for longer than the legend has existed by an almost incomprehensible margin. They do not know about the missile or the magazine features, or the tourists who come to look for lights in the sky. They know the desert the way the desert knows itself. From the inside, from long familiarity, from the particular quality of the heat, and the particular smell of the creosote after rain, and the particular texture of the pale playa earth under their feet. They are one of the rarest tortoises on Earth, found almost nowhere else, living out their long lives in a place that most people only know as a mystery. There is something quietly moving about that, if you let yourself think about it for a moment. The stars above the zone are extraordinary. There is almost no light pollution for a very long distance in any direction. On a clear night, which in this desert is most nights, the sky is the kind of sky that people in cities have largely stopped being able to see. The Milky Way is visible as a physical structure, a band of light with depth and texture, not just a smear but a thing with dimension. The silence on the desert floor is genuine, not the relative quiet of a suburban backyard or a park at night, but the real silence of a place where there are no engines, no voices, no ambient hum of human infrastructure for many kilometers in any direction. Just the occasional sound of wind through Lechuguilla and the vast, patient dark. It is easy to understand, standing in that silence under that sky, why the place accumulated the stories it did. Not because the stories are accurate, but because the place creates the conditions in which stories feel necessary. The human mind does not do well with unexplained sensory experience. It reaches for frameworks, it reaches for narratives, it reaches for the familiar shapes of mystery and wonder, and contact with the unknown. The zone provides the sensory experience and leaves the framework open, and people fill the framework with what they have available. In the 1970s, what was available was the Bermuda Triangle and Cold War anxiety, and a newly popular interest in extraterrestrial contact. In the 1980s and 1990s, it was the UFO tourism wave that swept through popular culture. Today, visitors bring their own frameworks, their own questions, their own particular version of the wondering that the desert seems to invite. What stays constant is the desert itself. The heat in summer reaching 45 degrees and making the air above the pale playa shimmer. The cold at night dropping sharply, the temperature swing that is one of the desert's most striking physical facts. The road that the US military built in 1970 to recover a missile that had no business being here, still running across the scrubland, still the path that everyone uses to reach the zone's centre. The small marker that indicates you have arrived at the place that has been called the Zone of Silence, standing in the flat desert with the sky enormous above it and the scrubland stretching away in every direction without interruption. The name itself is worth one last thought. Zona del Silencio, the Zone of Silence. It is a good name, a name that does real work, a name that tells you what to expect before you arrive, and shapes what you notice when you get there. The silence is real, but silence is not mysterious in a desert. Deserts are quiet. What the name does is transform a natural feature of the landscape into a category, a named thing with properties and implications and a mythology attached. Before the name, the silence was just the silence. After the name, the silence becomes evidence. It becomes part of the story. It becomes the thing you notice first when you step out of the vehicle and the door closes behind you and there is nothing, just the flat hot air and the pale earth and the sky. That transformation, from natural feature to named mystery, is the real story of the zone. It is a story about how human beings relate to the places that are strange enough to demand explanation, and how the explanations we build can become as real and as lasting as the places themselves. The Zone of Silence is both a geological basin in the Chihuahuan Desert and a 50-year-old human story about what that basin means. Both versions are real. They just exist at different scales and in different registers. The desert does not prefer one version over the other. It was here before the name, and it will be here after the last person who remembers the name is gone. The creosote will keep growing slowly, clonally, for thousands of years. Or the players will fill briefly after rain and empty again. The tortoises will move through the scrubland at their unhurried pace. The selenite will sit in its geological darkness, growing at the rate that crystals grow, which is slower than anything we can easily imagine. The sky will turn above all of it, enormous and clear and full of stars that have been there long enough that the question of whether anything strange is happening in this particular patch of desert beneath them is, from a certain perspective, rather small. But from our perspective, standing on the pale desert floor with a compass that may be spinning slightly, and a sky full of stars and a silence that is completely, genuinely real, the question does not feel small at all. It feels exactly the right size. It feels like the kind of question that a place like this was made for. And perhaps that is enough. Perhaps the zone does not need to be supernatural to be worth the long drive out from Ceballos. Perhaps the geology and the history and the silence and the sky and the tortoises and the crystals underground and the memory of a missile that landed where it had no business landing are sufficient to make it one of the stranger and more interesting places on Earth. Perhaps the silence itself, that real and ordinary and completely unremarkable silence of a desert basin in northern Mexico, is the most honest answer the zone has ever given to any of the questions asked of it. Not a zone of electromagnetic anomaly, not a portal, not a landing site, not a parallel to the Bermuda Triangle. Just a very quiet place, in a very large desert, under a very clear sky, where the Earth has done something unusual with its minerals and its biology and its long geological time, and where human beings have come for 50 years to stand in the heat and the silence and ask what it means. The desert does not answer. It never has. It simply holds the question, the way deserts hold everything they are given, patiently and without judgment, in the dry and the dark and the extraordinary stillness of a place that was strange before we named it, and will be strange long after we're gone. Sleep well, wherever you are tonight. And if the silence around you feels a little deeper than usual, perhaps that is not something to explain away. Perhaps that is simply the desert, reminding you from a great distance that some places are worth paying attention to, not because they are supernatural, but because they are real.